next presentation. So if you just want to message people or kind of let them know that we're going to be coming back here, we definitely want to make sure we're not getting too late of a start. We have people online that are expecting us to start around 1, and so we want to kind of call everybody back together here for the next presentation. We're going to be talking about the Ordinals SDK, and then we have Babbage and a few others. So, yep, very good.
Yeah, in a few minutes. I'm going to see if I can bring more people. Okay.
Big time. No, I just want to tell you, man, how impressed I am with you. I'm really impressed.
We're going to do a good thing.
Yeah. I mean, just really, you're doing a good job. Yeah. I really want to talk to you more when we have time.
Of course.
Okay.
This evening, I'll probably be at the Brazilian place.
Okay. I got the thing. We're all going to take. Well, at least my group, and we're going to take the cable car down.
Is it comped? I know it's like $400 for my team to go.
That's really up to Xiaohui.
Yeah.
He's the one with the budget. So
okay.
You need to ask him.
Yeah. We'll be down there regardless, I think.
But here's the. We're going to take you guys can if you want. We're going to take the cable car from outside the hotel. It's $8.
Okay.
And it will literally take us almost right to there.
All right. No, and that way we don't have to walk up the hill and everything.
Yeah, we can take the cable car there and back for $8, but it's cash only. So
perfect.
People have cash.
I'll do my best. Yeah. Otherwise, we'll just walk down there.
Otherwise, they can get an app.
Yeah. But I think, we don't have a problem. We don't have a problem walking either way.
Either, yeah. I like to walk personally, but right. It's a fun thing.
Walking's easy when the roads are flat, right?
Yeah. But yeah, ask Xiaohui and see if you're
cool.
Okay.
Hello, everybody. Live again on the air. So we're going to be coming back. We're going to be coming back in just about 5 minutes with the next presenter, I believe. I need to reset the. All right. We're just going to work through a little technical stuff here as we're waiting for everybody to kind of get settled back in. All right, very good. We're going to put up the slides for our next presenter here. We're going to talk about the Ordinal SDK. So let's make this full screen for everybody. All right. We'll confirm the clicker is working. Very good. All right. Are we ready to get started, everybody?
I'm ready.
Okay. Wang, are you going to be ready to come up? Do we have a presenter?
Mr. Wang is not in the room
Okay.
yet.
We're going to wait just a short while longer. We'll get everybody here. We'll have a few more people come back in. We're just kind of getting back from a lunch. There were some really great talks this morning. We had, of course, Xiaohui talking about the need for more developers across our ecosystem and kind of building the necessary infrastructure, right? Like the tools, the resources for developers, so that we can all have what we need to use Bitcoin properly, right? As we've said, we don't know what the killer app of Bitcoin will be, but I think a lot of the people who are up here talking about this stuff, our goal is to make that process of building that killer app 10 times faster, 10 times cheaper, and 100 times better when it does get built. Because, as Xiaohui said, we build the pickaxes and the shovels and all the tools, and then we give those tools to the developers who are creating apps and experiences for users, creating real value through enterprise adoption. Of course, as we acknowledged earlier, striking that balance between the enterprise side, the quote-unquote like the boomer way of building, and then also the kind of degen way of building, the grassroots up, ordinals, NFTs, all that kind of thing. Both of those kinds of energy need to be in this room. Both of those kinds of people are contributing to the ultimate vision for the BSV blockchain. And of course, we've said through the BSV Association, et cetera, that we look forward to continuing to support the enterprise evolution of the BSV blockchain, as well as letting some cool people come up here and talk about building some cool things as well.
Ty, Mr. Wang has arrived.
Okay, very good. So I think we're about ready to start our next presentation. We're going to be talking about the Ordinals SDK for sCrypt, and so we're going to be introducing some cool new concepts. And so please give a warm welcome to our next presenter, Mr. Wang. Just click this onto you. Your clicker is just up.
Okay. Good afternoon. Good afternoon, everyone. Hope you enjoy your lunch. So I'm Yiqiang Wang. I'm from sCrypt, and I co-founded sCrypt with Xiaohui about 4 or 5 years before. So it's been my honor to come here to give you a talk about our SDK for the Ordinals. So let us begin. Okay. So first of all, I want to reintroduce the Ordinals protocols. So like David talked us through in the morning, Ordinals protocol is a very straightforward protocols built for the NFT. And here I want to show you some details of the protocol. So let's take a look at this transaction. This transaction got 2 input and 3 output. And the first input have 5 satoshis, and which had a number from 1 to 5. And the second input has 2 satoshi. We can give them the ordinal number 11 and 12. And then we have this 3 outputs. The first output, then we can do the first in first out count for the ordinal number. So the first output will have the number 1, 2, 3, and the second output will have the ordinal number 4 and 5, and the last output will have the ordinal number of 11. And also, please note that there is a gas fee, right, for the miners. This gas fee also has an ordinal number of 12. So the protocol is very simple and it's straightforward. It just counts the input, which the ordinal number we got, and you count the output one by one, and first in, first out. And this is a very straightforward rule. So then we have this one set ordinals promoted by David, and here I only want to talk about the main differences between the one set ordinals and the original ordinals protocol. Here, the first difference is, I think, the main difference is the one set ordinals only have just like its name, it only have one single satoshi in the output, and it makes because it's we build on this on BSV blockchain, so one satoshi is enough. And but when The Ordinals are implemented on BTC. It requires at least 546, I guess. That's the limit. So it's more cheap and it's more efficient. And the second main difference, I think, is original-based indexing. So the original protocols, they implemented on BTC. You have to count the global ordinal numbers. It's a global state. So, but in one-set ordinals, we just can count, like David said early this morning, we just track the single UTXO where it comes from. It comes from an origin transaction, right? We can just trace back to the origin, and this provides us with more efficient, easier for indexing, and much more can give us much more performance. So the third, I think, the main difference is one Satoshi ordinals is inscribing in output. So we just put whatever we want to inscribe, the data we want to inscribe into the output of the transaction, so it can be very clear and straightforward. Okay, so sorry. So then I want to talk about why sCrypt want to integrate one set ordinals in the library, and why we need to build this SDK for developers. So as we know, one set ordinals is a layer 2 token protocol. It's built for the tokens, right? It's built for NFT and FT tokens, and sCrypt itself is what we can treat it as is a layer 1 smart contract. Developers only have to write the contract in TypeScript, but we compile the sCrypt, the TS sCrypt into the Bitcoin script. And why we need both things we want to combine those two things. The main idea behind this is we think that we treat like the token of it. The one set ordinals. It's for token, right? And we can separate the token representation and behind it, and with a token control logic, we can separate them. Or more specifically, we can decouple these two things, because the one set tokens can represent the token itself, right? And sCrypt contract can define how you can control these tokens, how you manage these tokens, right? And once we have these things combined together, we can define a very sophisticated way to manage the tokens. Please note, we can manage the tokens not from a single or a certain smart contract, but we can manage the tokens through different contracts. We can transfer the tokens from one contract to another, or the best part is, if we want to mint a token right now, we just can mint it, right? We can transfer it to like for a person, from one person to another, and then we can build some smart contract in the future. And this smart contract can manage these tokens today, and they do not have any requirements or dependencies. So we can we can just decouple them from one from another. So that will bring us a wonderful future, because we can do whatever we want in the future about a token we can issue now. and we can transfer them from contract to contract, meaning that we can have different controls of the token, or all defined by ourselves. So I think when we add the token, one set tokens with sCrypt, we can get infinite possibilities to create the future apps, to create something wonderful. It's I think, for example, we can create no matter it's DeFi or GameFi or some more advanced applications, we can use this method. Okay, so then I want to talk about how we combine these two techniques together to make it work. So it might be a little bit more detailed in tech, but I want to show here. So the first part you can see in green is one set Ordinals protocol. So I think David talked about it in the morning, and it's just like some Bitcoin script in it. It's op false, op if, and the odd, and then the content type, and it has some payload of content type and the data in it. And the script in yellow it represents the contract logic. It's also a Bitcoin script. And we just, how can we combine this together? We just add them up, right? So, for example, we have this we call locking script, which combines one set Ordinals protocols with sCrypt code, and it's a very simple inscription. It's a text, the hello world. You can see here. So this green part is still the one set Ordinal protocols. So this is hex for odd, and this is hex code for text plain, and this encoded code is for hello world. So the script in yellow is just a standard P2PKH locking script. So when we combine them together, we add them up, so we get a fully locking script for the Ordinals contract. Yes, that's how we combine these things together. Okay, so then we have this sCrypt-Ord SDK. It's a TypeScript or JavaScript standard library for developers who want to build the Ordinal protocols with sCrypt smart contract. It has some advantages. For example, it can provide effortless integrations with sCrypt and the one Satoshi protocol, and it supports both non-fungible and fungible tokens, and it has a dedicated provider to give developers more quick submit to the indexer. So then I want to show you some examples of this contract. So first we have this Ordinal NFT protocols. So here we declare a class and just extend the Ordinal NFT. So this contract is very simple. It's just the second here, the method, public method here. It's just in its body is just a P2PKH login script. We check the C, we check the public key address, and we check the C. It's just a basic P2PKH contract. So this is very simple. This is a very simple example to show how we can create Ordinal NFT with sCrypt smart contract in the sCrypt smart contract form. Okay, another very simple example is a hash lock NFT. right? Here we also extend Ordinal NFT base class from sCrypt-Lib, and we have this unlocking method. Please note this unlock method is very simple. It's just check the hash of the message equals to the hash you give to create the contract. So it's just straightforward. It's a hash lock NFT. Then, how to inscribe it? So the inscribe code is very straightforward. It's just a code of TypeScript. You can see we will just first we want to load the artifact for the hash lock NFT, and we have this text which we want to inscribe in a Satoshi, and hello sCrypt, and one Satoshi ordinals, and we got its message to by string. We hash it. We create this new hash lock NFT instance with this hash message, and we connected it with them. We connected it with the signers, with the default signers we provided. The last line, we just call the instance dot inscribe text. So this will create a transaction which includes all the informations above to generate a transaction to create this NFT. So it's very simple here. So developers they don't have to worry about how the locking script is generated. Like I showed before, it's a very complex in locking script form if you want to write it in pure Bitcoin script, but developers do not have to worry about it. It's just done by the library. Okay, here is another example for inscribe an image. Yeah, so we can get this image raw data from the file, and then we can just call the instance to inscribe image, and then we have this inscribed NFT whose data is just an image. Also, we can inscribe anything you want. You can inscribe anything you want into the transaction, into an NFT. So it's pretty simple and straightforward. Okay, so after inscription, how can we transfer the NFT from one to another? So here is an example. We can transfer the NFT, the Ordinal NFT, from the first here Ordinal NFT P2PKH contract to the hash lock NFT contract. This is the code to show how it works. So it's as simple. Here, as you can see, we declare the text. We create a recipient with this hash lock NFT contract, and we connect them with the provider. Here is the original P2PKH contract. We can you create it, which hold an NFT, and we can use this method from UTXO, or we can use get the latest instance from the original TXID. We can use both this method to get this instance, P2PKH instance. Then we have this. We can call the P2PKH transfer method on the P2PK instance. We need to give the pub keys to sign, and it will automatically find the signatures. And here, please note here as an option transfer. It means we want to transfer the NFT held by this P2PKH contract instance into this new recipient, which is the Ordinal P2PKH NFT. So that's how we transfer an NFT from one contract It's the simple and the most commonly used contract to this hash lock contract. Also, we can transfer from the hash lock to another hash lock. Yes, this code will demonstrate how to transfer between the two same contract. And yes, you can tell it's very similar to the previous one. So that's how we transfer the NFTs. Okay, so next I want to talk to you about the fungible tokens of the one-set ordinals. As David said early this morning, we got this BSV20, and I think it's a kind of a sub-protocol of the one-set ordinals, and it has two versions. So the first version is V1, and the second is V2. So here I listed the differences between them. So I think the main differences are, first, for V1, it has a global ticker, meaning that the ticker should not be the first ticker appears on blockchain is the real ticker, and if you have a duplicate name, it does not count. So in the first version 1, it has that feature, and the indexing rule is first in first. So when you first see this symbol or this ticker, or you first seeing mint transactions, and the mint transaction are ordered according to it appears in the block. So maybe the tokens are mint out. So the next mint transaction, although it's accepted by the blockchain, so it's in a block, but it does not count for the indexer because it's out of mount, right? So the minting verification is just the first. The V1 is its minting verification is done by the indexer, and its indexing cost might be high because we want to process all the transactions in a block to figure out who's first, who's last. So it may cost a lot. So the V2 version of this, it does not require, or it does not provide a global ticker. And every protocol, every BSV20 V2 has its own genesis, right? Its indexing rule is genesis tracking. We track every transaction from its deployment, from the token deployment, and we decide whether this transaction is provide a valid or invalid output of the V2 token. So its minting verification could be validated by indexer or and by the contract itself. For example, I will show this later. So also the indexing cost might be lower than the first version, right? So I think that's differences between BSV20 V1 and V2. So next, let's look at some examples. Here we can try to build this BSV20 V2 P2PKH, yes, and we just want to extend the BSV20 V2. It's an abstract class base for the BSV20 V2, and here you could tell it for the constructor it needs the token's ID, its symbol, its amount, its decimal, and its address for the current token owner. So it also has this unlock method, which is just a P2PKH unlocking script, just like it before. And this is pretty much the very simple version of the P2PKH contract, which can hold a BSV20 virtual token. then we can also build this hash lock token for BSV for the fungible tokens, right? Here's the same. You could see the same. We need to construct from the required fields of BSV20, provide them with this constructor parameters, and we can declare this unlock methods, right? It's just still a hash lock, right? Okay. Then if we have this token contract, then what we want to do is to deploy this smart contract on chain. So here's the code how to deploy the contract onto the blockchain. So we just create this. For example, we create the hash lock contract here with some parameters, right? And we just when we want to deploy it, we just can call the deploy token method of this instance, and then we have our smart contract which can hold this tokens to the blockchain. After that, we could mint it, right? For example, if Alice and Bob, they both want to mint this token, right? They both want to mint this token. We can do it in the same transaction. For example, we can have this Alice. He needs this token to be transferred to BSV20 P2PKH contract, and Alice is the same, but they do not have they have their own address, right? And here the hash lock is a contract we just deployed to hold the token itself. So we can just call hash lock the method, unlock method. We pass in this message to unlock it, and then we can declare we want to transfer this amount to 2 of the token to Alice, and 5 of these tokens to Bob, and we can do this in the same transaction. Yeah, so it shows that Alice and Bob can mint at the same time. Also, they can transfer the token from one to another. Yes, this contract or this method is code here shows how to transform P2PKH BSV20 from one address to another. Yes, it all looks like the same as the code before. We just want to call the unlock method on the P2PKH instance, and we declare a transfer. Yes, it's the new instance, the new address, but they got the same token ID, same symbol, same amount and the decimals, and then we need to it should have provided by public key as a parameters. Then we can call it. So this is the transfer from one address to another. Yeah, also we can transfer the fungible tokens from the hash lock contract to BSV20 P2PKH contract, and it's very similar to the mint part. Okay, that's pretty much the code I want to show you, code demo I want to show you today. So if you are interested, we also built this demo app. It's sCrypt-Ord.io. You can try it. Try this app. It's fully functional. Yeah, you can inscribe an image, inscribe an text, inscribe both BSV20 version V1 and V2 on our website. So if you would like to see how it works, it's a straightforward app you can try. Yeah, another thing for the developers who want to build on the one-set ordinals, we also have this what's on chain plugin here. For example, here when you solve transaction, you can click here to say if it's a BSV20 transaction, it gives you more details about the transaction. For example, here is a mint transaction, I think, right? Yes, and here is a transfer transaction. What it looks like and what it contains in the transaction. You can just click the extension here and say what's inside the transaction. Okay, that's pretty much it. It's all it is. Thank you for watching. So, any questions?
Questions? You can come up here. Anybody? No. All right. Well, thank you very much.
Okay, thank you.
I'm going to try and get the sound.
All right. So we're just going to get the little.
I'm going to try and get the sound guy we talked to earlier to come help us with this screen. I think if we just put like a backdrop behind the screen, we've got a lot of sunlight coming in through the front, and that would help out a lot. I mean, it would have really been nice to be able to see a lot of the code that was up on that last presentation. Yeah, I will.
Put that on.
Yeah. So sorry about that, folks.
All right, everybody. We're just going to make a few minor adjustments to our little in-person setup. This shouldn't impact the stream very much. We actually lost one of our little these fuzzy things. We actually put these on top of the mics if you're wondering to reduce some. It's like a pop filter kind of thing. So we're just getting that, and then we also got some things with our screen. We have the sunlight shining through here, but that shouldn't impact the live stream, I don't believe. What I'm going to do is put up the slides for the next presentation. That's actually going to be ours. Let's see, can I? All right, are we all good here? It looks like it. Okay, so I have a dark background for my slides, everybody. Is this more acceptable? Are we moving that behind there? Okay. Pardon us, guys. Just I'm sure you can see on the video feed, we just got some people coming in behind me here. But don't mind them. We'll just get started here. So, oh, good. Okay, so it sounds like the in-person audience is much happier now with that. Back there, so the sun doesn't shine through our projector screen. All right. So I think my clicker's working. Good. So next up, we're going to be talking about some things, and I think it's going to be, hang on one second. It's going to be from fundamentals. So I think this is going to be a little bit less technical presentation, but more accessible to some people. So we're going to start from the beginning. We're going to zoom all the way out and talk about why we're here, and why it made sense for us to bring our team down here and do all this stuff. We're really excited. We love the energy of this event. Want to talk about contracts. Really, what it comes down to is you have people, and they get together and they want to exchange. Before we had computers, we had the idea that you could just get together and make an agreement with people, and if you all kind of signed this piece of paper, which kind of put your name on this agreement, then you could facilitate things. And that's what a contract is, right? It's people who get together, they have a meeting of the minds, there's an offer.
Can you click one more time?
Oh. Are we good? Yeah. Oh, yeah. So, yeah, for those that don't know, my name is Everett. I'm the founding president of Project Babbage. Now we'll go to the next slide here. Okay. So yeah, talking about contracts and whatnot, and I'm going to do this. Here we go. Right. We are building a system. Babbage is building a system that allows you to bring that identity, that idea of you're putting your name on a contract, onto the digital world. Physically, you could sign a piece of paper, you could make an agreement with people, and that was a contract. But doing that digitally is really useful. You need identity. You need to know who's part of the contract, and you need to know what they're agreeing about, right? Those are kind of the things. And then you need to be able to keep record of that, and that's what the Bitcoin blockchain does. So zooming all the way out and thinking about what this technology is good for, right? We really need to focus on the utility of this technology and actually, there's some fun we can have and make some memes and go on Twitter, and that's fun. But there's some value that we can add to the world. There's some things we can do better. The internet right now has some problems. Maybe that's the understatement of the century or something. But we got these data breaches. We got all these passwords that you have to use everywhere. So I just kind of want to take a minute here and appreciate where we are in the world and maybe lay some foundation pieces for people about what we can do with this technology, and then we'll get into what my company's about, what sCrypt's about, and then we'll talk about we integrated some things together. Babbage and sCrypt are now integrated. We've actually got sCrypt contracts working in kind of the Babbage system that has been created, and we think that's really cool. So we'll talk about that. But first I want to lay some foundation pieces, just for the sake of those who might not understand some of the basic things about, look, we're at an sCrypt hackathon writing some code and building some things. That's really cool. And I'm really looking forward to seeing what people build. But why would we build those things? Right now on the internet, you don't really own your identity. What do I mean by that? Identity is fragmented. You have one identity through like Twitter, if you have a Twitter account. You have one YouTube channel. You have a telephone number. You have an email address. Maybe you have, how many in this room have more than one email address? And then you have to try to figure out which one you signed up to particular services with. And that's a hassle. So fundamentally, but what I mean by owning your identity is all of the apps and services and platforms that you use, they should plug into you. They should put the user at the center, meaning that you have one identity, and the things that you do, they kind of can tap into that with your permission. But then you get to move across all of those different apps. So if you update your address with the USPS, that would reflect across like everything that taps into and consumes your address, which is kind of on your device. You're at the center. And that's the vision of own your identity with Bitcoin on the internet. So that's the first little thing, right? When you have identity, you can get together and do some things. There's this concept of a thing called keys. A key, a cryptographic key, which is the technical term, but don't get scared and run away just because we're using some technical terms. If you've been here this long, through a lot of the things we've talked about, you're hopefully not too scared of having some terms thrown out. But the idea is you have this way of communicating with other people that's private, and when you own your identity, you have keys, which represent or provide a way to represent digitally your identity. They're not the end-all be-all of your identity, but they're part of it. And you can use that for secure communication, and you can also use that for digital signatures. You can sign digitally, and that goes back to the idea of contracts. We're building up some foundation pieces right now. We have identity on the internet. We can do things, and apps kind of plug into that. And we move beyond. And we now enable people to communicate privately with one another across their identity, meaning I can talk directly to, say, my friend Mike or Braden or anybody, and I can do so privately. And the app that I'm using is just a facilitator of that. It does not have access to the things that we too are sharing in a private context. You can publish things. And when you publish, you could digitally sign. So you can say, I am actually putting my digital signature on the thing that I created, and then anybody can verify that that goes back to me, and it's attestable, and it's linkable. digital signatures can also be used to sign off on things like digital assets. So we have physical assets in the real world, right? What is an asset? It's like your house, your car, your phone, anything that you own. You have the concept of, especially for large things, you have the concept of ownership and you have the concept of title. And if you sell your car or your house, you have to sign the title, right? Or the deed. And that's using a physical signature on paper. So digital assets are kind of the same. It's like, what if you own something digitally? What if I own the right to publish a song that I uploaded? That digital right, it's kind of weird, but it's like an asset in the same way as my house or my car. And I can sign and I can transfer it to someone else. And what Bitcoin did is it kind of came in and it said, well, we can do these digital assets and these digital signatures, but we found a way to do it without needing to trust a single person to be in charge of all of it. And then it also introduced the idea of adding value and scarcity of particular types of digital assets into the equation. And when you combine identity with signatures and private communication and the ability to convey assets digitally, then we get some parallels with what we have in the physical world. We have the idea that, in our physical world we can get together, we can make agreements, we can sign things over, we can trade, we can barter, buy and sell, we can haggle with one another at a flea market or something about the price you want to pay for something. And that's capitalism. That's like the idea, subject to law and regulation, which means there are limits on market power. But you have a free market. You have people that voluntarily exchange things. And that's really powerful. Because on top of a market economy, you can create a lot of things. And so we have this in the physical world with capitalism and the idea that we can kind of exchange and trade and have a free market where we can transact with one another, set up the terms and conditions under which we would like to deal with one another on a voluntary basis in a free market. And so Bitcoin is kind of that missing piece that allows us to mirror that same phenomena that emerged over a couple thousand years in our physical world after we kind of got done being barbaric and we actually became civilized as a human society with law and government and the things that are necessary, but if you ask me, limited. And now we can do that digitally. We can have digital assets, digital agreements with one another, and these agreements don't have to be big. It's possible to kind of buy or sell a car or a house or a digital or some type of asset, a very large asset, even send a very large amount of money with a bank digitally without Bitcoin. You can call your bank and do a wire of $10,000. You'll pay, maybe $100 to wire your money. But with a distributed system where we don't have to have these central people that track everything and that we have to trust for everything, Bitcoin brings that threshold of exchange for digital commerce down to the level of a single Google search or a single listen to a song created by an artist. When I want to listen to somebody's song, how much is that worth to me? It's not worth a lot. But if 10 million people want to listen to someone's music and appreciate the art that they created, that person can make a living off of that. And that's what Bitcoin's about. And that's, I think, one of the core reasons why this technology is going to be important going forward. It's going to bring down the cost of doing business digitally. It's going to give people the power to exchange, and it's going to put people at the center of those equations. It's going to enable them to move across many platforms without needing to update their accounts on many different systems, because Bitcoin isn't an account-based system. The users themselves transact and track their own information. Every app that uses Bitcoin is going to plug into the user at the center and facilitate the ability to sort of, can I access this kind of information about you? Yes or no? And the users like software, their operating system on their computer, the wallet, the Bitcoin management layer that they're going to use is going to ask them, and they're going to say yes or no, and it's secure. The app can't just reach in there and do whatever it wants without the user permission. So that's really powerful. And I just wanted to take some time here at the beginning to kind of zoom out and talk about these are the things that we are building from a high level in a way that everyone can understand. Because while I did slip up there and mention cryptographic keys and maybe scare some people, other than that, I think that was a pretty non-technical explanation of why this stuff is important. So if you're here because you think that's important, then in my opinion, you're here for the right reasons. And we're going to build some really cool things together. So my role, what does my company do? Why is Babbage important? Why have I got a bunch of people working with me on making this stuff happen? Well, because I went to them and I asked them if they would like to take a whole bunch of irresponsible risk and do the most irresponsible thing they would ever do in their whole life and come work with me on this new startup that, may or may not make money and may or may not succeed, but we do it because we believe in these things. And that's important. We should do this stuff because we believe in it. And so the role of my company is to provide the tools similar to sCrypt. And I'm about to talk about, why does Babbage need sCrypt? What is sCrypt? All of these things, we're asking the real questions, right? We need to think about the foundational pieces. What is required in order to arrive at that world that I described earlier, where people can haggle and barter and exchange and trade in the market? What is needed for that? We need a few key things, and Babbage is going to provide some of those things. So what I'd like to do before I jump into what my slides actually are, and I think I only have like 5 slides, so that's why I've been sitting on this one for a good while here, is I'd like to just provide a little bit of context about, now that we've laid these foundation pieces and kind of built from first principles what we're about and what we're talking about. Babbage provides the underlying layer, like the thing that all the apps kind of tap into in this standardized way. And it does so in an accessible way for developers, in a standardized and interoperable way too. So then you might think, well, clearly Babbage just wants to be the only way for you to build apps. We just want to be at the center of everything and make ourselves indispensable to the entire world economy. But that's not true. In the same way that you can use different web browsers, you can use Google Chrome, maybe on your computer, maybe you can use Safari on your iPhone. You can visit the same websites. And we have interoperability. That's a big word, but it just means we can use the same things. And it's standardized. It's very simple. But we don't have that in Bitcoin yet. And Babbage is going to make that happen in Bitcoin, so that if Babbage goes out of business, it's not going to be like Money Button or Run or RelayX kind of went down. We're going to create interoperable systems where we can be replaced, so that everybody forever can have a protocol, a standard mechanism by which they can facilitate or create apps that do this stuff, that enable these things. And those apps keep working even if you use a different wallet or a different underlying Bitcoin management identity layer. So that layered approach to technology is important. And we're going to make sure that it's done in a way that at every level we are not we want to make sure that if worse comes to worse for my company, someone else can step into the breach and start creating better software. And yes, compete. I want people to build better wallets, but I want those wallets to be interoperable. I want us to agree about what it means for an app to plug into Bitcoin, what it means for an app to act as a facilitator of private communication between people, what it means for an app to allow you to exchange and to digitally sign. And so it's not about the app, it's not about Babbage, it's not about Bitcoin. It's about the people and the things that it becomes possible for these people to do for the first time in the digital world, which are analogous to going into a grocery store and picking out whichever kind of food you'd like to eat and buying it in the physical world. So we're going to enable this stuff. And it's going to be really cool because we're going to extend the capabilities of the internet to enable payments, to enable attributed content, meaning I know who produced something or they signed it. If they want me to know, right, I can check. Private messaging, right? All of these things. So that's kind of what Babbage does. without delving into specifics. I could delve into a lot of specifics, and I might eventually if you guys have questions about it. But basically creating the identity layer, the Bitcoin management system, the wallet, and then letting people use it. But what about contracts? Right? We started this discussion about what is a contract. And Bitcoin allows you to sign and exchange digital assets. But how do you do that? Well, that leads into what is sCrypt. Because sCrypt is a way to use Bitcoin and use this identity system, or use like a wallet to create particular kinds of transactions that have particular terms and conditions associated with who can own or transfer or create or destroy particular types, in fact, any type, I would go so far as to say, of digital asset. So that's what sCrypt is from first principles. That's what Babbage is from first principles, and that's why Bitcoin is important, in my opinion, from first principles. And on top of that foundation, you can do a lot. You can create a whole digital economy. And I think we're going to do that because it would be kind of fun. And a lot of the developers, Xiaohui started this morning. Developers, developers, developers. We need many people to build many kinds of applications. When you start to use these tools, right, we, as Babbage, and I would venture to say sCrypt as well, are creating tools that make it 10 times easier and faster and cheaper to create new kinds of experiences for users, put them at the center, reduce the barriers to entry for digital contracts, digital rights, digital payments, in the future of online identity, where when my credit card expires, which I do have one in my wallet that's expiring in March of 2024, I don't have to go on 17 different websites and update my subscription because I think that's kind of annoying, and this is 2024, March of 2024, in fact. And I'd like to not have to live in that world. So when I was young, I thought to myself, how can I use the internet to build really cool things? And then I discovered capitalism and started to educate myself, and I was like, that's really cool. Why can't we do that on the internet? Why are there all of these perverse incentives with all these influencers, all this disinformation, all these sponsored content and ads, privacy invasions, people not owning their identity, fragmented systems where it's not about the user, it's about the big, huge companies making all this money and raping all of the rest of us over the coals, right? We're not going to live in that world for much longer for one of two reasons. Number one, because the people here aren't going to take it, and they're going to decide that enough is enough, and they're going to get, pretty angry, and they're going to go build stuff. That anger is going to convert into drive, a drive towards building something better. Or because, I happen to think that if that doesn't happen, the masses, the population, the average people of this world are not going to want to live in this digital, air quotes, utopia, which is not a utopia, it is in fact a dystopia, for much longer. I think we have about 3 to 5 years to create some stuff, to make the digital economy work for the average person, to put that person at the center. And if we don't manage to do that within that time, I guess everybody here is going to be out of a job, for one. But I hope to see people here execute, create things, deliver value, and that's what Bitcoin's about, if you ask me. So that concludes the first little thing I wanted to talk about on my first little slide here. And now I have, I don't know how much time left, but I think we have a good bit. So we'll move on to the next slide. Right? Wait, actually, no, we're still on the first slide because we know what Babbage is. We know what sCrypt is. Why does Babbage need sCrypt? And let me actually do this. All right. So sCrypt is a smart contracting platform, and Babbage gives users pens and paper. So when you have pens and paper, you can write contracts, but only if you have, a smart contracting platform. So that's kind of why Babbage needs sCrypt. It's a framework, and it's some really cool tools for actually building this stuff. So sCrypt enables advanced terms and conditions that people have talked about this morning.
Sure. Someone has a question?
Yeah.
Hi, this is Gavin. You know,
Hi, Gavin.
you mentioned your background with economics and like when you were really young, you looked at the internet and what you
Sure.
wanted to build. Can you just tell us about a little bit about your story, about how you got to where you are right now?
I can get into a little bit of my background if you guys would like. Got my first computer when I was 6. There was a Sparrow Club. I'm visually impaired. I don't see fully. I see about maybe 20-30% as much as the average person. And so there was this fundraiser to pay $5,000 to get me my first Braille computer in 2006. I then, went and did some mischievous things with that computer being 6-7 years old and figured out how Windows CE 4.1 works and started to explore the menus. Humanware built a good device back then, the old Braille notes. Anyways, I've always, ever since then, I basically knew that I was going to do something with computers because it just fits my mind so well, so deterministic. I love computers because when you write the code, it's always user error, right? It's always something that we didn't think about as humans. It's not the computer, like just deciding it doesn't like us. It's actually, believe it or not, it's actually humans who have made mistakes, and that's why we can't do what we want to do. Whether it's I who made the mistake or the person who wrote the program for my Charter Spectrum DVR, which I don't think very highly of that user interface. And there's many others, but the point is, programming is really cool. Building stuff for the internet is really cool, but I wanted an internet where I could build stuff and I didn't feel like I was exploiting the people who I was building for. I was told about the slot machine analogy when I was learning how to write code and how to build apps. I was told you have to make your app into like a slot machine effect where you have this addictive experience where you have to create a fear of missing out so that all of the users get addicted to your app, literally. Like chemically addicted with dopamine. That's how it works. And that's how you keep people coming back to your app. I was told that you have to force people to stick into your platform, that you have to build a moat, that you have to have this concept of a sticky app where you can't leave. You can check out, but you can never leave. And you're stuck. Can Mr. Beast leave YouTube and keep his 200 million subscribers? Not easily, not all of them. We need to change that. So that's what I realized. I realized I wanted to build stuff for the internet, but I didn't want to exploit people. I wanted to create systems of direct exchange, where if I want to go and play my mediocre piano music and upload it to a music platform, I don't want that platform to put ads in front of my music. I want the people who listen to my mediocre piano music, which maybe, I don't know, maybe it'll get good someday. I want those people to pay me directly for the fact of listening to my music, right? And I think people told me I should do market research and I should ask people whether this is a good idea. But what I realized is, regardless of what they said, I really wouldn't care. I was just going to do it anyways. There was never a question. So, that's a little bit about my background, I guess. And that's why I got into programming. I thought programming was really cool because I wanted to build things, just a cool way to solve problems and build fun things. But it stopped being fun when I learned that the way to succeed on Web 2.0, which is the version of the internet everyone knows and loves right now, to build for Web 2.0 is to exploit people, to bring them down, to make them less, to make them addicted. And I wasn't having that. So that's why I'm here, personally. I don't, everyone has a different story about why they're here. But what I want to do is give people the knowledge and the tools so that if you are like me in your beliefs, in your core values, in what you believe the internet to be and what it should be and how it should work, how it should reward people, how we can contract, how we can exchange, right? How we can communicate privately or publicly and have the choice. I want to give you some tools, and I just want to let you know that, you're not alone, maybe? I don't know. That's why I'm here. So now I'll move on, I think, to what we can do with this stuff, right? The next part of this presentation is probably going to get a little bit more technical. So for those non-technical people, you have to understand that this is now getting into the nuts and bolts. We believe these things. We have these goals. We have these end results. How are we going to get there? What are the ways that we actually create, transactions that define these terms and conditions under which people exchange? How do we put the user at the center and do digital signatures and encryption and all of these things to keep everything private? That's really what we're going to get into now. So, that's where things are at. Babbage is a system that defines user identity and creates a standard interface and mechanism that puts users in control by putting a wallet on their device and then allowing that wallet to be swapped out in the future. And then all the apps that they use plug into that interface so that apps can start to be built around that infrastructure, around that core component. And I want to see many wallets. I don't want to just be the only one, but we created one, and we published all the specs. That's the really important thing. You can go on openstandards.cache and read all the specs that we actually wrote for making this stuff work. So anyways, that's where we are. That's what Babbage is. And then sCrypt, of course, allows you to define terms and conditions for these contracts that are between people. So Bitcoin transactions have outputs, which are things that you create, and then amounts, which are like the amount of bitcoins, which is this currency, this new kind of concept of a currency that are associated with the outputs, meaning how many bitcoins does this output, which are these things that you've created, represent, and what terms and conditions are attached to how one could go about spending those outputs. So, we want to essentially make advanced transaction capabilities on top of Babbage, and sCrypt is the best way of doing that, I can assure you by far. Xiaohui and team, you have built the best way of creating smart contracts on Bitcoin, and so I'm sure everybody here understands that. So let's have a round of applause for Xiaohui and sCrypt team. So we're going to plug sCrypt into an identity system and a standard interface for a wallet, and we're going to open that up. We're going to make it so that anybody can build an app. It's no longer one wallet that shuts down and then all the apps just stop working. The app runs on a thing called local host. And if you're a developer, you'll know that's on your own device, meaning it cannot be in the cloud, at least from fundamental. You could do a proxy if you want to do a proxy wallet in the cloud, that's fine. But there's going to be an interface that all the apps plug into on the local device, meaning there's no concept of a web server that just goes down. I would love to, a local host proxy for something like a hand cache even, and then you can just kind of run everything that way. But make it so that if API.whatever.com goes away, can we please continue to use our apps? Please? It would be nice. I think we can do that. Is that, how many times? It's been 2-3 times. Money button and then relay. How many more times, guys? Let's standardize this stuff. Let's get all the wallets on board. Yep. Come on. That's going to be something that we do this year. I'm going to set that as a goal. I want to see our industry standardize all the wallets, at least the interface between the wallets and the apps, on a local host or a local substrate of some kind by the end of this year, so that if one of those wallets goes away, all the users and all the apps are not left in the dark. I think it was Luke who wrote a thing called, BitChat Nitro? And I think it had to be written 2 or 3 different ways to support the 2 or 3 different wallets that it supported because they all had different APIs. Is that correct?
Yes.
Okay. Just making sure. So,
Begrudgingly, yes.
Right. And we're not happy about that, are we? We should get together and agree about this stuff. That's all I'm saying. So, advanced transaction capabilities with sCrypt. Customized tokens and assets. So sCrypt enables you to create any kind of contract that represents different things, and it's very open-ended. And basically, it's just there's a concept of a Bitcoin input script and a Bitcoin output script. And a wallet should just allow you to create arbitrary ones of those. It should capture the leftover Satoshis, leftover Bitcoins as change, and pull it back for the user to keep around for future transactions. And if you happen to require more as input funding for your transactions than what you have provided yourself, the wallet should ask the user if it's okay to spend that kind of money. Maybe you allow an app to spend up to $5 a month worth of Bitcoin, and then it should fund that for you. And that way you don't have to worry about doing your own UTXO management if you're an app developer. That kind of thing we should think about. So arbitrary digital assets that can be created and redeemed by users within their applications using sCrypt contracts. That's what it means for Babbage and sCrypt to be integrated, and that's kind of why Babbage needs sCrypt. There's also the concept of a wallet holding different types of assets. And you think, well, we have like simple, what is it called, pay to public key hash. That's just like the normal way that you hold Bitcoins. But other ways, other script templates, other types, those exist. How about we have the concept of a basket that can hold particular types of outputs? And then you do anything you want, any kind of script. And then the user gets to decide whether a particular app gets to access tokens that are residing in a particular basket across all apps. And then all apps can manage particular types of tokens, and all the tokens get to do whatever they want, whether you like ordinals or whether you think that there's other approaches that might work. Just another type of asset that can make it into a basket that is held by the user in their wallet and where all apps can plug in. That kind of thing. That's what I mean by sort of these customized tokens and assets. And the final thing here is called UTXO first integration. What I mean by that is that there is a really important concept in Bitcoin called making everything based on what is in an output, and then exchanging that output or tracking it or making everything with respect to an output. And that basically improves scalability, and so it's really important for that reason. So that's kind of the basics of this. All right, and why might sCrypt then benefit, and let me, there we go. Why might sCrypt then benefit from an integration with Babbage? Well, like I said before, identity and key management, right? We need a wallet to manage the keys and to allow apps to kind of use those keys, but only with user permission. And those apps are the layer that should integrate sCrypt contracts, right? I don't want a wallet to do everything. I don't want the wallet to be like like Wonder Bread. I want the apps to provide all those user interfaces and all those ways that people connect and exchange. The wallet should sign, should do the digital signatures with user permission, should do the encryption with user permission, and the app should just be a facilitator of that and a provider of the necessary script templates, smart contract templates, all of that. So identity and key management are important when it comes to infrastructure. And what I come to offer you as the sCrypt development community is a way to manage keys better, and I'll get into that with the integration. So then we have an application development framework, a standard interoperable way to build apps and to create transactions, to encrypt data, signatures. Even identity certificates have been talked about in my wallet, and it's like, how do you have a little ID card for like a library card or like a thing that attests that maybe you went through, I don't know, some typing test on the internet. You can now type 50 words a minute and you got a certificate for that. Like little things, right? You can do that stuff with identity certificates, and then you can verify with user permission. Those are things that are in the wallet that we've created. We want to open this up. We want it to be interoperable. We don't want to be the only wallet, and I'll drive that point home. It's just that we need to make sure things are architected in the right way, and we need to put the interfaces locally on device in a standardized way. Right, I already talked about change generation and input selection, but basically, as an app developer, I probably shouldn't have to generate a bunch of change outputs, follow Benford's law, and do all this stuff, with generating change across multiple outputs, distributing it, things like that. So if you manage to unlock on behalf of a user for that number of Satoshis, then what the wallet should do is it should just automatically create new outputs that capture that and then let you sign that, and it would work properly. And then input selection is, suppose I just want to create a simple output. What if I just want to inscribe something? Well, request one output from the wallet, give it the output script, and then it should find the necessary inputs, do all the input selection wallet side, so apps don't have to think about that anymore. And then users can be put at the center because now apps don't have separate wallets. Now you have one balance across all your apps. All your assets live in a single place, held only by you, and all the apps plug into it. That kind of thing is important. Yeah. It's really important. Wait. Sorry, I was impersonating Joe Biden there with the whispering like that. It's really important, guys. Permissions and baskets. I talked about that already. So, yeah, basically users should be prompted to make sure it's okay, everything is good, and then they should be, the app should be allowed to proceed with its action. Of course, if the user denies permission, the app should get an error, and the user's not good with this, so you can't do it, right? Baskets are for holding particular types of assets. They can have any type of custom script, and we all just kind of, there's protocols that can be emerged for standardizing what goes in what basket, and we've got to figure that out. Be something to talk about, but right. Finally, interoperability and standardization. Really important. I think that's enough said about that. It's really important. So, peer-to-peer, is that what's next? Yeah, peer-to-peer smart contracts. So, Alice and Bob. We always talk about Alice and Bob in the peer-to-peer context. Want to get together and exchange in the physical world. If Alice and Bob wanted to, say, walk into a room and say, hey, let's flip a coin. And I'll put in $1 and you put in $1, and whoever wins the coin, whoever calls the right one, they get $, right? That's like a contract, an agreement. It's surprisingly difficult to do that in the digital world without trust. Yeah. Something that simple we haven't really fully solved in an interoperable way yet. I want to see a coin flip app where Alice and Bob can do that digitally without having to trust third parties to generate random entry, because maybe Alice or Bob could go pay off the third party to rule in their favor. And and you can do things with that. So I want to see that coin flip app, and that's a very simple request, but I want to see it with an interoperable underlying framework. Right? I want the wallet, I want the identity to be owned by the people involved, so they can directly exchange. That's like a really simple thing, but we have the tools now, and I can demo that a little bit later. But yeah, so here, two people directly talking to each other over some communication, right, to agree about the terms under which they would like to deal with one another, and then the money moves according to the terms and conditions that were set. Nobody can cheat. We leave a record on the blockchain. It's accountable. It's distributed. It's secure. That's important. That's what Bitcoin provides. So Babbage supports full SPV, simplified payment verification. What that means is you can send transactions directly from one party to another. You don't need to rely on a centralized chain scanning and indexing system for that. You can simply send the transactions, and everybody involved can verify that the other parties are not cheating. And guess what? What if one of them is cheating? Does anyone want to try to think about what that might look like? What if I want to deal with, say, I don't know, Braden over there, and what if I'm trying to pull one over on him? It's peer-to-peer. There's just the two of us. What is the recourse? How do we deal with this? We need to introduce a centralized authoritarian state to rule over all of us so that sorry. That's not the right approach. How about if I tried to pull one over on Braden and he sees it because it's on the chain and we have a system that is competently architected? He has choice. He doesn't have to deal with me. I'm a cheater, right? That's how it works. Peer-to-peer. Person to person. Smart contracts. So, and scalability with SPV, so we can verify that people aren't cheating and stuff. Building an infrastructure for that, we have that in our systems and continuing to improve. There's some new specifications out called Beef and Bump and Arc and a bunch of new things, and we're getting all that stuff plugged in, and love to talk about that later as well with anybody who's interested. I'd love to help other wallets, other apps, other systems. Let's be interoperable. Let's figure out how to exchange this stuff properly. So we can stop having to rely on central third parties. Because every time you do, your costs of business are going to increase. And eventually, they're going to realize, wait a second, we're a central third party. We can pull one over on people. What a concept. So, sCrypt provides powerful layer 1 capabilities, meaning you can do contracts directly in Bitcoin. And then you can track those things on higher levels, and we'll get to overlays and what that means a little bit. But basically, you can manage state directly. What that means is I have my checkbook. And when I write a check to somebody, I keep track, right? I keep track of my state. I have to back it up somewhere, right? What if I drop my phone in the toilet? Oh no, I can't keep one copy of it. We need to design synchronization protocols so that you keep it and you own it and it's yours, but don't drop your phone in the toilet. Well, if you do, you have a way to get it back, right? That's the idea. So people manage things directly, and we have that in play. What can we do after that, right? We have people manage their state, and I keep track of all the things that that are related to me. There's another philosophy of Bitcoin that says that everybody has to keep track of all Bitcoin transactions. And people think I should have to keep track of, say, I don't know, David Case and Xiaohui, they have a coin flip. But if I'm not involved, why do I need to know about that? And the answer is I don't, right? I mean, I might like to watch and see who wins, but like with their permission. And we can register things and have multiple parties involved. But the thing is, people keep track of where they lie with respect to particular transactions, particular exchanges, and they do so in a way that doesn't rely on someone else doing it for them and telling them what is the view of state. They need to manage their own state across all their applications and what tokens they hold and get access to that, right? That's what that means. Managed directly by users. So that's a simple framework with identity, scalability, and contracts for two parties to get together and exchange. Overlay systems on top of Bitcoin are more advanced state tracking agents or record-keeping witnesses that witness particular things that happen when those things are of concern to more than two people. Because if it's just the two of us, we can kind of talk about it directly and, you know, we both know what's going on. And we have demos of two-party state management. We also have demos of multi-party state management with overlays. So I want to upload my mediocre piano music for everybody to have the opportunity to listen to it. How do I do that in a peer-to-peer system? The answer is we have to figure out where the music is. We have to kind of say, hey, it's over there, or it's over there. And then people can look over there or wherever it is, and they have to kind of be able to access it. So that's where something like an overlay network happens. Now, overlays can be done, well, state tracking systems in Bitcoin can be done in a couple different ways. Way number one, we can go to the miners, and we can say, hey, Kurt, will you give us all of the state that we need? And that's one way of doing it. A lot of things work that way now. Another way of doing it is we source things directly. And I guess you could also say, and you know, we can discuss this further as well, but there's a hybrid where you kind of have the miners as a backstop, and you primarily rely on state coming in from the parties to those transactions. But if I'm the one uploading a song, if I'm the one who wants to make sure that you all have the opportunity to hear it, then I should go to whoever, you know, manages that particular overlay network, or I should pick a place or set one up for, you know, if no one else does, then I should create it. And I should kind of let everyone know, like, you can go over there if you want to access these particular UTXOs, these particular Bitcoin tokens or outputs that represent the songs or your ability to contact me and purchase the key necessary to decrypt and play them through your speakers. So you can architect systems like that. You can do so in a scalable way because overlays don't need to rely on trust, not fully. Overlays can consume transactions directly from the parties who create them, sourcing them that way. There's even multicast systems that more technical, but we can get into that if you guys want. And they can consume this state, and they can track things, and that's really cool. So anyways, overlays track multi-party state, such as a list of all songs published by a lot of different people, and they're distributed. There's no fundamental requirement that every single person involved in certain types of overlays has all of the information. You can have many different people with different kinds of information, and then they can kind of get together and talk about things. So these overlays can track UTXOs. These UTXOs can represent contracts, offers, the acceptance of offers. They can represent any number of digital assets, and you can trade those assets in multi-party ways. And that's how you get to that market, going all the way back to the beginning. Now we have a digital system not controlled by one party. There's different markets, right? That overlay, maybe I have one over there, and they're different markets, right? Like Fred Meyer and Walmart. Different places I can go to exchange. I have choice. There's not a single one that everybody must use. Now, sometimes, if you want to buy Apple stock, you have to go on the New York Stock Exchange, and that's kind of like the way to do it, right? But Apple chose that, or maybe the government forced them, but different ways of tracking state. It's fundamentally, architecturally distributed, and no single wallet, no single overlay, no single application will be in control of this market. It will not be co-opted, and that's important. Because for hundreds of years into the future, we're going to set up the systems and the interfaces and the standards by which this happens. And then we're going to use them. How long has it been since Internet Protocol version 4 has been standardized? It must have been at least 4 decades by now, I think. About 30 years, yeah. So we haven't had to change it very much. We've added on. We've done more things on top. Of course, the Internet keeps getting bigger, but once we agree about the standards and the way we can get together and exchange and interoperate, right? That's really powerful. And I'd like to see that world in my lifetime. 30 years is a long time. The Internet's come a long way in 30 years. I can stream this live, and we can get lots of people to watch it. I'd like to see that be IPv6 multicast. That's not the way it works currently with our current streaming, but we'll get there. Anyways, the Internet's really cool, and it's been around for a while, and we've come a long ways in 30 years. So imagine 30 years on top of standard interfaces, standardized replaceable wallets, standard ways to exchange value digitally. 30 years of digital capitalism on Bitcoin. That's the kind of thing that I get excited about. That's why I wake up every day and challenge myself to do the absolute most difficult thing I can think to do that particular day in pursuit of what we need to build in order to make this stuff happen. And people should do that more. We should build more fun things. We should build a world where we want to exchange, where we feel right about building apps and software that people use. Not that we're exploiting them. They are our equals. And they have choice. And if they want to leave, let them. Why? Because, well, you weren't good enough. If someone builds a better user interface than you for, say, text messaging or music, if someone builds a better way to buy and sell books or to read books in an e-reader app, would you have them forced to stay on your platform? Or would you give them the respect and the dignity and the autonomy to move somewhere else if they were in fact better? And I ask, if your answer is that you would force them, by what right? And there's not very many legitimate answers there besides, oh, well, they chose to exchange one time. We kind of, baited them into a second one, a third one, and a fourth one. It kind of just hooked them and made them addicted. I don't think that's legitimate exercise of market power, if you ask me. But, to each their own. So overlays are the future, in my opinion, for tracking state across multiple people. They're like markets where people get together and exchange, talk about different tokens, what those represent, the terms, the conditions, the exchange, right? All of that stuff. And I think I'm really excited about that. Right. So they enable access to particular types of data, such as songs. All overlays are going to represent, different things. There's going to be different rules on certain ones, right? Like the stock exchange is going to be pretty heavily regulated, so you'll kind of have to be in sync and keep track of everything. And there'll only be, a private few people who could run that. But then you have more open systems like the song playing and the song exchange system that I'm pretty excited about. And we have demos of the song one, and we're building demos for the stock assets. But we'll talk about that more in the coming years. But the song one is really cool, and it's more open, and anyone can kind of host whatever they're wanting to host, and then you get together and exchange. So the nodes, which are the markets or the particular overlay operators, they get together and they can coordinate and synchronize specific data they care about. You don't have to track everything unless that's the rules of your particular system. You're kind of free to synchronize what you want and go forward from there. So it enables compliance and the removal of malicious data. So suppose someone uploads pirated music. Well, guess what? If you upload it to the overlay that I run, you're going to be out of there. And I have an identity system in front of the transaction submission. And not only will I ban you from that particular song, but you're not uploading any more music. And if you think you have more than one blockchain identity, you're going to force yourself back into a fragmented world where everything is how it is now. So joke's on you if you're going to pirate music. No. Anyways. We're gonna make some ways to moderate and to make things honest, and to make it so that if people do malicious things, yes, there are ways of removing it, and maybe other people are going to keep hosting it, but those people can have fun getting DMCA'd and getting their IP routing taken away. So, anyways, this is unbounded scale. Because everybody runs what they can handle. Everybody invests in hardware. Everybody gets paid when people actually use their particular overlay for hosting. You can charge for lookup. You can charge for transaction submission. You can create the rules that you want to create for synchronizing data on an overlay network on top of Bitcoin for something like music or anything else. So scale is unbounded because the source of the transactions is not from a single point, but from many, many different points. And then you verify it all using the simplified payment verification, SPV, and so that part works. Right. People just only kind of host what they want, and they coordinate and let each other know based on an informal thing, or maybe more formal if you get bigger and get together and talk with different people to relay particular things between overlays that are interested in the same things. But yeah, that's how overlays work, folks. Questions? Do you want to see a demo of a coin flip? I mean, I'll run through the code at least, but questions first. Let's see where you guys at? How are we doing on time? All that stuff. Looks like we got 15 minutes, I think. You want to see a demo? We got a few questions, or? Let's do questions first, and then we'll see how much time we have. So, be brief with your question, I'll be brief with the answer, and we'll get to a demo, hopefully.
Yeah, this is not exactly a question, but originally I was trying to get these people to come and spice it up. So I want to have some kind of like instead of just people giving talks, have some kind of like let's say debate. I think one thing I propose maybe after the last speaker is done, we can kind of get together with indexers versus relays. Okay.
Sure.
That should be spicy.
I love that debate. Yeah, we should.
Yeah. I mean, it's not really a debate, but just David.
Yeah.
Yeah.
It's a space. Yeah.
Just spice it up. Yeah.
Sure.
So, It'll be great.
Let's do it.
Since we were talking about the verses, we
Yeah,
want to make sure.
I think we have one brief thing. Actually, I don't think there's the slides for. I don't think we have that yet. So why don't we go through the questions and then maybe we'll do a little demo and then maybe we'll transition into what's next.
After the formal talks, we can get the whiteboard and stuff. Just spice it up. Yeah. All right. And one more thing I want to quickly add. Originally there was supposed to be no streaming because I don't know how to set up all those. It's like a magic to me. So thanks for Project Babbage. They just offered and they just come here all the way and help us to set up. So thanks. Set up all night to just set up so people can have fun. Thanks.
Of course.
Great, thank you, sir. Okay, so my question's going to be much more on the practical side of the world where I live.
Okay.
So what I do every year is I send out contracts to people, and I need them to sign the contract, send them back, and I also need to file formal appeals with the contract. So it's electronic signatures,
right?
And I need wet signatures.
Okay.
But now with what you're telling me, I can get them to get online and electronically sign, right? And so that electronic signature can be, but I just need to go get the states to recognize it, which I can do.
You can.
So I'm eliminating having to send out all this paperwork coming back and forth. They can just get online and click on a button and electronically sign, yeah?
Of course.
Oh, this is insane.
And it can be linked to your government identity.
Okay.
You can link the keys, and you can do that privately so that only the parties involved actually see everything.
Yeah.
And I'd love to help you build it. Let's chat after the event.
I'm all in because, I've been working with the state and local authorities for 33 years. So, this is awesome. So I'm definitely going to talk to you after. Thank you for that answer.
Of course. Next? Yeah, electronic signatures, the legislation, I believe, was passed in the U.S. a while back, and you have to be able to link the identity and certify that before the signature is created. And then there's different levels of it, but
I know some of the counties in filing the appeals demand a wet signature, but that's just I've been changing the laws in the state of California regarding that already anyway.
Good.
So it's just something I have to do is introduce in the next session.
Good.
And it may already be done. I don't know. I've been out of space for 3 years.
Well, yeah.
So I need to find that out. So.
And one thing you can do is you can take the wet signatures if you have to have them.
I do.
And you can scan them, and you can have the hash of the scan on the chain, and you can leave a chain-based record of the physical document or the scan of that photographically, and then you can have that linked only for the people that need it.
So this is going to get real crazy because I'm actually on groups that actually advise the counties themselves of how to come into the next generation.
Right.
And they're already doing upgrades of all of their systems.
Sure.
So now I'm going to throw this at them, and they're going to be like, what?
I'd love to back you up on that.
Okay, awesome.
It's going to be fun.
Thank you.
All right, should we jump into a little informal run through of some code?
No more questions?
Further questions before we jump into a little demo?
If I could say, I don't need a mic. Okay.
Well, we just want to
Sure.
sure.
Yeah, my question is, it sounded a lot like technical standards.
Mm-hmm.
And I'm curious, are you on the BSV Technical Standards Committee?
No, so we're involved here at Babbage more so, and maybe, I don't rule it out in the future. I'd love to, work with those people and get this stuff through, but we're more so through it's called the BRC process, or the Bitcoin Request for Comment. It's less formal. Kind of anyone can write one of these requests for comment, and they contain, essentially descriptions of different things. And I would encourage collaboration there, and I would also welcome input from the Technical Standards Committee on kind of various BRC standards that we've created. So basically the track works like there's someone that comes up with an idea and they write a BRC. Then we can create some reference implementations for that BRC, kind of get it backed up with are people going to actually be interested in using this, and does it get some traction? Do we get code developed, open source components? And then after that happens, then we bring in the TSC, the Technical Standards Committee, which is responsible for kind of the formal process of solidifying and aligning everybody towards that. And then what that leads to is the final stage, which is actually creating certification for those after the TSC process. So that way we can actually set up kind of certification programs for companies who follow those TSC recommended standards, that their business is in fact compliant and maybe can use certain brand marks or something like that. It's early days, but the BRC process, then TSC, and then it goes to certification after implementation, of course.
So you are working with the TSC, or is that just a hypothetical
my
synergy?
Role, I was just describing what I believe to be the BSV Blockchain Association's process.
Okay.
So I have been in contact with many people through the BA, and I'm not speaking for those people, but I'm just articulating my best understanding of where I believe their process is at with standardization.
All right, thanks.
Of course. All right.
Hi, Ty.
Sure.
This is Brett
Yeah.
Banfi. Throughout the conference so far, I've been bringing this up and highlighting that I'm a very lay person when it comes to this topic. So I thought, what better opportunity than to just ask this question outright and directly.
Sure.
Maybe my ignorance will help, others who have similar questions about the same topic. So the question is about IPv6 specifically, and about the interchangeability of IPv6 addressing space with the Bitcoin, the address of a Bitcoin address. So as I understand it, these are sort of like the same number of length in bytes. I could be getting that wrong, or they're at least, there's similarities between them. So can you talk to me a little bit about maybe the opportunity that represents to have an IP address be directly translatable to, be able to receive and be the destination for transactions and data that's coming through securely?
Sure. So for those that aren't aware, IPv6 is a new version of the Internet Protocol. It's a way to get stuff from one place to the next on the Internet. And there are these things called IP addresses, which represent those ultimate destinations of traffic. Previously, there was a thing called IPv4, which was a little bit more limited because we didn't have as many addresses. There was only 4 billion of them, and there happens to be almost 8 billion people in the world. So it's a little bit problematic. With IPv6, what you can do is give each individual their own IP address in one model. And so just by knowing that person's IP address, you could contact that person and message them, like send them a message through that, and ask them where or how they would like their Bitcoins, and then you could pay them. And so I send a Bitcoin transaction directly to somebody through their IPv6 address after I first talk to them, make sure they're online, make sure they're all good with it, and make sure we have a common understanding about how this person is going to get paid, what specific key or destination that Bitcoin is going to. And then after I do that, I can make that transaction, digitally sign it with my wallet, and then I can send it off to that IPv6 address, and that person can receive their Bitcoin that way. So that's kind of how you can do a peer-to-peer exchange with IPv6. There's other uses of IPv6 that are more complicated with Bitcoin with respect to like multicast groups for transaction broadcast to miners and overlay nodes, and then also getting updates about transactions that you care about from the miners and from the overlay nodes, such as getting a Merkle proof, which is like the thing that confirms that your transaction has been included in a block in the blockchain. But IPv6 and Bitcoin are friends, and we're going to use IPv6 for a lot of cool things in Bitcoin over the coming decade. It's a long-term investment, but foundation pieces are starting to be laid finally. It's been a long time, but people are starting to understand things and talk about things, and I'm really liking the energy around it. So, great question. All right. I'm going to try to be a little bit, what's the word here? Spontaneous. And I'm going to put my screen over to mirroring, and then I'm going to use OBS to change the source to actually my screen, and then we'll make sure we're all good, and we'll go from there. So I'm just going to say say go over to this guy, and I want to right. Okay. So what I think I've just done is make it so that if I go back to this guy here, my screen should be visible on the projector, correct? Hang on. I'm just going to change this here. So I'm going to run up a little bit of a see display capture, and we'll just go there. Okay, I think I'm streaming, and I have the projector up, so we got some slides here, we got a bunch of stuff. So how does Babbage integrate with sCrypt from a code level? That's an interesting thing to explore. This is just going to be a brief explanation, but we can get into it. So I have Visual Studio Code, and I have a coin flip, and just pardon me panning around for the first little bit. I'll stop panning once I get everything where I need it. I'm going to go to coin. I think I'm already there. Okay. So an sCrypt contract contains a constructor. Object-oriented programming. You have classes, and you have a constructor. And you have methods, ways to operate on that particular class. The coin flip contract is an sCrypt contract that facilitates the flipping of a coin between Alice and Bob. There's Alice and Bob again. So I'm going to make this a little bigger if I can. And I'm going to move this. I'm going to get everything set up here so that I can see it and so that you guys can see it. And then we'll talk about this. So this is a smart contract in sCrypt. And maybe you can see it up on the screen, guys, can you? Yeah. Okay. So, firstly, contracts have parties, right? The identities of the parties. Here's Alice and Bob. Identities are represented by public keys in this contract, meaning they represent the users who are acting in this context, Alice and Bob. And then basically we need a way for Alice, and this is going to get more technical, so Alice and Bob are going to want to exchange they want the ability to kind of, in a trustless way, arrive at the result of a coin flip, which is Alice and Bob both put in money, and then we get to a coin flip at the end. Alice is first going to start by creating this contract with the constructor, and is going to reveal a hash. She's going to say, here's some hash, and here's a timeout, meaning Alice is offering Bob, includes Alice and Bob's public keys, a hash, and then the timeout, meaning this is how long they have to finish their contract. And that's what Alice puts in at the beginning. So what is Alice going to hash? She's going to hash a number, 1 or 0. And she's also going to hash a nonce, combining with that number. Nonce meaning this random value. And put those two things together in a hash such that later she can reveal her number, but make sure that Bob can't guess it before she does reveal it. So Bob does not know what Alice has picked at the beginning, but Bob knows that Alice cannot change her answer after, if she were going to lose otherwise. So then later in the contract, we're going to store Bob's number, meaning Bob is also going to pick a number, 1 or 0. And at the end, if Bob's number is equal to Alice's number, then Alice wins. If the numbers are different, then Bob wins. We're also going to make sure that Bob has to double the money in the contract if he accepts it. So we have a contract state here, and the state 0 means that the contract has been offered by Alice, but not yet accepted by Bob. And then there's going to be another state, which is that once Bob has accepted the contract, we are in a position where he has doubled the money, and now it's up to Alice to either reveal the money, or if she doesn't, or reveal the winner, or if she doesn't reveal the winner, then after the timeout has expired, Bob can come in and take the money, because it's assumed that if Alice becomes non-responsive after Bob has accepted the offer, Alice must have been cheating. So after, say, 30 seconds of unresponsive Alice, Bob can say, okay, well, I win. So that's what happens. And then also, it's on-chain permanent record that Alice was not honorable. So there's the reputation. Right, now we know that if someone cheats, and the other person had to resort to using the timeout, that's how it goes. And then they get put in a timeout. Right, that's funny. That was a good one. Here's the constructor. We're just assigning all of our properties here. So Alice sets this up with just the first few, and then eventually Bob is going to come along later. So in computer science, object-oriented programming, we have a class, which is like a way to create things of a particular type. We have the constructor, which is a way to construct instances of that type. And so you call the class constructor to produce an object which represents an instance of that. Once that has been constructed, in this case by Alice, we can then go and operate on it using the public methods. So these public methods are like ways to interact with a pre-existing or already existing object. That's how sCrypt works with contracts. sCrypt contracts have assertions, which are like little things you have to check off. If you make all of the assertions true, meaning I assert that in order for this to be a valid way to execute this contract, these things must be true. That's how it works, right? If you pass all the assertions, then you check all the boxes, and you move forward. So if the contract state, as originally defined by Alice, is, say, 0, meaning that it is in the offer state, and if Alice wants to call this function, which is declared on line 58, then she can cancel the offer. So if Alice made an offer to Bob, and then Bob just turned around and walked out of the room and said, joke's on you, now you locked up your money and you never get it back. Well, guess what? Now Alice can get it back. So that's how that kind of thing works. The signature, go ahead. Can we get the mic?
With the assertions, it just has to make it to the end, right?
Yeah, you have to pass all the assertions in a particular public method of interaction with this contract instance.
So in reality, this would read like public cancel offer returns, Boolean.
Yeah, and if that Boolean is true, like after, so it's like, think of it like you're going down this list of things, these assert things that are in here, and if you get to the end, right, so it's like, if the assertion fails, suppose the state is 1 instead of 0, then, well, you're done. You just can't keep going because you had a failed assertion, your program crashes, and you failed to redeem, or you failed to make that particular way of using this contract work.
Okay,
so
I got it. But then the assert keeps it all from crashing. It just stops.
Yeah. Okay. So we're making these assertions one by one, and then by the end, if you've gotten all of them to be true, then you get to, you win, basically, or you've successfully interacted with the contract in that way, right? In the way described by that particular public method. Subject to those assertions, right? Now they have to be true. So if the contract state was 1, then Alice could not cancel the offer because, well, Bob would have already accepted. So suppose, I don't know, Braden, if I made an offer to flip a coin with you, and then you accepted my offer and you doubled the money, should I, after you've accepted it, and you've doubled the money, should I just be able to say, well, I'm canceling the offer and taking all the money? Sorry. No. You put in some of that money. And so that's why the state has to be 0. And the signature has to come from Alice, meaning that Bob can't cancel the offer for Alice and take the money, because that wouldn't be right. If I offered to flip a coin and then you were like, well, thanks, I'll take the money, bye. No, the signature has to come from the person who made the offer when you're canceling. That's the first little way of interacting with this contract. If we're in that state, then Alice can cancel. The person who made the offer is Alice. The person who might accept is Bob. Bob can accept the contract. This is going to get a little bit more complicated, so I'm going to kind of go through it at a high level here. Bob can accept the contract if the contract is in the offer state, and if he has signed properly, meaning Bob can sign to accept. Alice cannot accept on behalf of Bob, and because Bob has to put in some money, and so so the contract state must be there. Then we're going to make sure that Bob has picked a number of either 0 or 1. So previously Bob's number was unknown, and when Bob saw the offer, he doesn't know what Alice's number is. So he's got to pick a random number between 0 and 1, right, to kind of make his part of the randomness part of this contract. And so, right, he has to pick 0 or 1. And then we're going to update the state of this contract. So we're going to say this instance has Bob's number of whatever Bob provided. And now the contract state of this contract is now 1, meaning now it's in the accepted state, and Alice can no longer cancel. And then the last part here basically builds a new state output. What this means is Bob has to make a new instance of this contract by virtue of accepting the old one and spending it, creating a new one in which he has doubled the money. So there's a multiply by 2 in here, I believe. Yes, on the end of line 76, we have a multiply by 2. And that means Bob must create a new revision, a new updated instance, a new state of this contract in which the money is doubled. So that's how that is. And then the last part here is just the logistics of making sure that that actually happened. So that's how Bob can accept. Now, there exists a new instance in which Bob has accepted. So now there's 2 more things. One is that Alice could reveal the winner. So by revealing the nonce, the random number that she picked, and by revealing the number, 1 or 0, that she picked, previously Bob didn't know what that was, but we know that, but Bob can know that it hasn't changed, meaning Alice didn't cheat and only pick the number after Bob has picked his number. So by doing this, what we can do is we make sure when Alice is going to reveal the state that the offer has been accepted by Bob. Then we make sure that the nonce that Alice picked is, has sufficient entropy. That check isn't strictly required, but it's there just to be robust. Then we're going to verify that hash is correct. So we're going to verify. We're going to take the actual hash of the nonce and the number that Alice picked to authenticate it, to make sure that it is really based on the number that Alice had committed to at the beginning. Because if that was different, then maybe Alice might have cheated and only picked a number after Bob had picked his. So we verify that. That's the function of the lines from 87 to 90, and then then we know the value is correct, right? We know that Alice is revealing a true number by this point. The assertions mean that we can't get down past line 90 unless what Alice is revealing is in fact what she had originally committed. And it's fair because Bob didn't pick a number until Alice had already committed. So both of them are fair. And we can see if they are if the numbers are the same, then Alice wins the coin toss. And otherwise, the signature can be signed from Bob, meaning Bob gets to decide about where that money goes, and Bob gets to win the coin toss. So that's how Alice can reveal. And now, of course, we go back to that thing where we said earlier, what if Alice drops off and doesn't reveal? Well, then after that timeout that they agreed about in the beginning, Bob can just say, okay, well, you're not being cooperative. I'm just going to claim the winnings myself. And that's what this last little function is. It asserts that we're in the accepted state, that the timeout has passed, and that Bob has signed claiming the winnings. So just a little helper at the end, and that's the coin flip contract. So
So with the, can you show one of the asserts on the screen again?
Sure.
Or just one of the whole functions I think would be best.
Let's go to the bottom one or something. Yeah.
Okay, so the way that I'm seeing this is you could take what's in the body of the assert function, say if this contract state is equal to 1n, and you could do the and if this check sig and this time lock.
Yep.
If all those are true, then Bob wins automatically after delay.
Sure.
Right.
Yep.
So it's just a different way of doing this, and I'm trying to understand why exactly is it
multiple asserts.
Well, no. I'm trying to because where is the delay happening? It's in the time lock, I guess.
The time lock. So basically, when Bob creates the transaction in this time lock, for example. So firstly, let me address what you mentioned earlier with the and. So with the and everything, it's the way that I build it is just for convenience. I could have put all of that into one assert. But when I build contracts, I think of it like a checklist. It's I'm making this checklist, and we can check these things off one by one, and if all of them check off, then we're good. That's just the way that I do it. But in terms of the time lock, it's basically, there's a thing in Bitcoin that allows you to create a time lock on a transaction, and then you can basically make sure that transaction cannot happen using a thing called n lock time, and end sequence in the transaction that makes it so that it's not possible for that transaction to exist or be accepted by the network until after that time has passed. So by making assertions based on that, we can make sure that Bob can't do that until after the time has expired.
Okay, and so then what's being called is going to be an instance of this.
Yes.
And can you scroll up so I could see like what the because there's multiple methods.
Mm-hmm. All these are methods. Yep.
Yeah,
There's a constructor.
Okay, there's the constructor.
So we're constructing these properties into the instance when it was first created.
Okay, so
to update that instance.
Alice hash is her
what she originally committed to in an obfuscated form so that everyone knows that it hasn't changed later.
Okay.
So she thinks of her number, she hashes it in such a way that she commits to it without revealing it, and then later we'll check it after Bob thinks of his.
Okay.
Right?
And then contract states is...
you can see above just a little bit. It's basically just 0 originally, and then once Bob accepts it, it goes to 1.
Okay, so it's whatever is accepted or offered, and then I assume that once it's accepted, offered, okay. So then Bob number is whatever he chooses.
Yeah, after he goes to accept, or when he accepts it, he declares what his number is. There's no reason to hide at that point because he's doubling the money, so he doesn't have to do a hash like Alice because he's just accepting, and he doesn't have to kind of hide his. But
all right, cool. So you set all these things in the constructor. You have this instance, and then you're going to call one of these methods.
Yep.
And that's going to change. So let's see what we have. We have cancel offer.
Yep. As long as the state is 0, and as long as Alice has signed, the offer can be canceled.
Okay, and then it'll go into a different state, right?
Yeah, well, what'll happen is you spent it, right? So you have like a contract that is represented by like a Bitcoin output, which is this thing. You can think of an output like a thing that exists. And then when you go to cancel the offer, you're kind of unlocking that thing, and it's kind of just freed up when it's in this state. When you're canceling, it's kind of freeing it up so it doesn't have to exist anymore. And then all the money that was in it gets unlocked along with the thing itself and freed up for Alice to use for whatever she wants. So it's kind of back into her pool of money or whatever.
And so then at that point, what happens to that instance?
Well, it's gone. It's been spent. It's been consumed. It no longer exists.
But in your
in the accept
code,
offer,
I suppose in your code.
Right.
Yeah.
In the accept offer, by contrast, we're actually asserting that another instance has been created by the same transaction that consumed the old one. So that's how it lives, right? It kind of goes into a next state because we're actually making assertions about that new transaction, and we're forcing the new transaction to have to create a new instance of the thing itself.
That's what the thing that that Xiaohui would always talk about.
The stateful, the push TX it's called, or push transaction. We can.
Okay, so some of these methods use the op and create a brand new.
Some of them require the creation of a new instance as a condition for the old one to be consumed, right? So the only way that you can consume is by creating a new.
And so in this, where is that new thing, and then how do you keep track of it in your code?
Well, so we have it is pretty magic.
I want to learn how to use it.
But basically, at the end here, we're making an assertion that the transaction has created a new thing, and then once the transaction gets out to the miners, then everybody can kind of look on the blockchain or look in an overlay or have it indexed by an indexer, and can then find that new thing and use that new thing versus using the old thing. And so by virtue of that process of it being published like that, we can continue to interact with the contract, it now being in its new state.
Okay.
Does that make sense?
Kind of. I'm thinking of more from like a user interface developer, like JavaScript.
So you can think of it as a thing that if you don't want to think of it like the thing gets broken down and then recreated, you can just think of it like an object, and then things can happen to that object. Sometimes the object could be destroyed. Other times it lives on in a different form or in a new mutated or updated form. And that's how we propagate the state forward with sCrypt.
And so when it's updated, though, like in your JavaScript code, are you still using the same instance, or do you have to wait and then go get a brand new instance?
So in the JavaScript code that actually interacts with this class, we would parse the new script that had to be in the transaction that spent the old one, and then we would kind of create a new one, but it would have hydrated values, which are such that, like, we have the values from the new state, from the newest instance.
Oh, okay, cool. So that
Yeah.
answers my question.
Yeah,
Okay.
yeah.
So then you don't really have to worry about this. You're just using the same.
Right.
Okay, that's good design. Thank you. That answers my question.
Yeah, it's genius. Xiaohui has done really great work on making this stuff happen.
Yeah, we
And
should do a demo of some of the TypeScript.
I'd love to
JavaScript,
see,
yeah.
I mean, I don't know how you guys are feeling. I could run through the actual way in which this is interacted with in the app. Like I could say, okay, well, let's go into now how we're deploying this with Babbage specifically, and then how we can redeem it. But I want to tap into how we're feeling here and see where everybody's at. Other questions, or what are you guys feeling?
Yeah, very elegant code. Thanks. Oh, it's,
Yeah. Do we have audio from the? Yeah, I think we do. So.
Okay, cool. Yeah, very elegant code. I like the style. Not questions, but just some. I think about it as like a refactoring suggestion. So because it's 0 and 1, maybe you can make it just Boolean.
Yeah, it could.
So you don't have to even check it.
Yeah.
And I don't know if that's going to be a demo about. I think there's two things. First is the state can be a Boolean, and also probably the number they chose can.
Sure.
0, 1. Just
Yeah. Is heads and is accepted.
That's no.
It could be a Boolean.
Third option. Yeah.
Yeah.
And is the demo going to be like has some kind of like front end to it, or is just command line? Because if you're not, I think Taylor's going to add a front end, and he will submit as part of his hackathon. So
we do have a front end. I don't really trust our there's parts of our thing that it's a work in progress, but it is there, and it does. This is a React app, actually. If I can show that there's components here. We have artifacts. So these are the contracts. There's an operations file that basically contains how the front end is driven by. We have a function for creating a challenge from Alice to Bob, and then we have a function for Bob to list his incoming challenges using the Babbage kind of basket system with the Babbage wallet, the standard wallet that we talked about earlier. And then, of course, all the people doing the signatures and everything. All of this is code that's just kind of here. And I'll just kind of go through. I'll describe what the functions do without really, delving into too much depth at the beginning here. So yeah, there's, check for challenges. There's a function to accept a challenge. So Bob receives a challenge from Alice and wants to then, propagate the state of that challenge forward. So there's some code that does that. And yeah, so we create a new instance, and there's the output that is created by the transaction. Yeah. Yeah, you can use the new keyword in TypeScript to construct a new instance of it.
There's a couple different ways, actually, depending
Yeah.
on what information you've got as far as
Yeah.
raw transaction or
From the locking script. Yep. Yep. And we'll find different ways to interact with this stuff and really make this stuff as easy as possible for as many people as possible to use. That's really what it's about. So yeah, then I don't know. Let's see how Veet is doing. Is it npm run dev? I'm sure some of the people who worked on this are getting a little nervous right now as I'm about to pull this up, but let's see how we're feeling today. Okay, so there you go. Well, let's see, stage line, right? All right, so we have a standard wallet. Runs in my system tray here called MetaNet Client, and I can kind of pull it up, and here it is. Yeah, so these are all of my apps that I've used most recently on the MetaNet. I have Tempo here, I have PurePay, and a few others. I can see my balance. I can click on any of these apps and kind of see all the transactions, the ways in which I have interacted with this app. So on the left here, I have my actions that I've done with this app, and on the right I can see some permissions or things that app has access to with respect to my identity. So this is the wallet that I'm talking about that everything kind of plugs into. Now that I have this running, I should be able to search for somebody to challenge. So maybe so I can search for, and I'm not going to go through the whole process here. In fact, how about I challenge? So there's a thing I can do, which is just to challenge myself. So maybe I can find myself here, right? And I'll challenge myself of, what is it?
Does the house take a fee?
Not in this one. You could write that in the contract if you want. You could code that up as an additional terms and conditions, right? But I'm going to just preemptively open my network tab here just in case this goes kaput. But we'll see how this goes, guys. This is a hackathon. Well, we'll see if we can make some things work. I'm going to pick heads, and I'm going to try to flip my coin. So here's a transaction request. My wallet, and it's asking me if I'd like to create this transaction. I'll just say, sure, let's do it.
All right, so then right now,
Mm-hmm.
let's just recap what just happened.
Yeah, it made a new instance of that contract. Alice, created that.
But is there now a UTXO?
Yeah.
It's on the chain.
It's on chain.
3,000.
Yep. Yep.
In order to unlock it.
Mm-hmm. I can now go into my MetaNet client. I can actually click on this app, and I can show that UTXO on what's on chain. So let's just go to what's on chain then.
So now you're going to message him, and you're just like, here's the UTXO, here's the
Right.
security box with the lock.
And there's the 3,000. And what I love about sCrypt is that you don't have to deal with all of this anymore. So big thanks to all the people that made this stuff. We don't have to write all of this anymore because, some people like doing this. Xiaohui might like doing this, but there's people that might not like to do this. So, yeah, you can write cool things with this. So yeah, we got the CTXO. I think the timeout is set to 1 minute right now, so I don't know if this is gonna. Let's see.
It said 1 already.
Yeah. Well, I will go ahead and click on this, and I can see I have an incoming challenge, and it shows up as right now. Identity resolution code where I have an identity certificate that's linked to my wallet, and it's supposed to resolve to my public key, but that part of our system is still under development. I'll just go ahead and see what happens. I don't know, did I win or something? Oh, look. I won because I challenged myself. All right. So, yeah, I got a 3,000 sat input here coming in, and I got, what? Oh, this is just me. No, sorry. This is me accepting the challenge. So, we'll see. I don't know if this is going to work, guys, but the concept is you win. Okay. Not sure exactly what happened.
So let's pretend that you had just an app.
Mm-hmm.
We didn't do the identity managed through Babbage or whatever.
Right.
It was just a page that's able to read these transactions.
Right.
And then you would text the address to this UTXO.
Sure.
And then the other person would open it, and they're basically just using that app to insert the sCrypt code that's unlocked or not.
Yeah.
Is that possible?
You can exchange it peer-to-peer.
I think your way is probably better with the Babbage thing, but I'm just trying to understand it from a fundamental level without adding a bunch of pieces. You know what I mean?
Yeah, of course.
Because I don't.
Right.
Then when we went to the load, your challenges, it's well, how did that happen?
Yeah. Well, it received a message from the challenging user over a messaging bus, by which those users communicate.
Which is fine.
Yeah.
It's for the demo purposes. It just seems like it's all on the same server.
Of course.
You know what I mean?
Right.
Whereas
if it was 2 computers, and we have done it with 2 computers, it's just we're kind of scared to do it, but because there's lots of early stage stuff here, but fundamentals are good. Okay. And yeah, we have so we can see the input here and the output. All right. Well, I want to wrap up. We did a little demo and we kind of got some things going. So thank you very much for sticking with us as we've kind of made this stuff happen. What is it? Okay. Is that mic on? Is it blue? Is it red?
Oh, there we go. Can you open back up your Babbage wallet or whatever it's called, where you've got the different? So on the TXID, like you've got the inputs and outputs. Are those just generic descriptions, or do you guys have any sort of way of like standardizing the communication to an end user of what their historical interactions on a contract were?
We have the way to put descriptions in, and you can then hydrate that in the UI. A lot of these say no description provided, but some of them, have other ones. So, oops, that's a different one. Yeah, so I can I can show here, but yeah, you can see like you created a coin that you challenged, all of that's standardized. It's just represented in the UI, and then for the inputs and outputs themselves, there's also a way to describe what you're doing when you consume an input or what you're doing when you create an output. You can see some here, but yeah, fundamentally it is part of the API between the app and the wallet, where the app gets to kind of provide that information and let that user know what's going on with the particular assets we're manipulating, whether it's a contract, a token, anything like that, or just Bitcoin itself. Okay. Any other are there other questions, or where are we at time-wise and whatnot? Okay, let's go ahead and wrap up, I think. Thank you very much.
I thought you had a question.
Our next presenter. Okay, I'm going to give the mic to Kevin Healy. Oh, sorry.
Go ahead, Ty. Hey, buddy. This is Gavin.
To Gavin.
I just thought I would introduce the next speaker. This guy's going to talk about the. Okay, we got this one. Thank you. It's going to be the digital. See if I've got this right. Matt Walsh from Orlando, Florida. Yeah. Matt Walsh from Orlando, Florida. So it's going to be, it sounds like what he's going to do is it's going to be there's going to be an off-the-record talk at some point, so it's going to be about the digital currency for the age of Aquarius. So it should be definitely something we haven't ever heard of before, at least I haven't. So definitely going to be interested to hear, Matt. All right, buddy. Yeah. And this is going to be the mic for you.
Oh, okay. Clip it on.
Yeah.
Ty, did we set up my presentation on this computer?
We did not.
Yeah, so that might take just a second. We have to download it. It's in your email.
Why don't we do a 10-minute break, Ty?
Yeah, bathroom break, please. All right, 10-minute break.
Everybody come back in 10 minutes.
I'll set this here for now.
It's on my profile, pinned at my page.
Test, test, test.
All right, everybody. The stream is all good. The slides are all good now. Maybe we'll start to kind of pull back in here with our presenters. So just a couple more minutes, and then we'll be back with the next presentation. The final presentation for today is going to have, I think, 2 parts. There's going to be an online part, and then there's going to be an offline part just for the people who are here. So we'll go through the online part first. We're just still getting final things set up here, and then we'll be back for the world currency for the age of Aquarius. All right, everybody. We're coming back for our final presentation of the day. So as we come back here, guys, for our final presentation, I'd like you to give a warm welcome to Matt. He's going to be talking to us about the world currency for the age of Aquarius. So here he is. Just put that on.
Thank you. Give me a second just to clip this on. Oh, God. What the heck? Okay. Check 1, check 2. Boop, boop. All right, if somebody wants to round the troops, probably don't want to miss. I'm coming. With that camera, can you get the podium and the whiteboard, or can I migrate between?
Keep you in frame and we'll be dynamic. Keep you in frame.
Awesome.
And then we'll get the whiteboard when you're
Okay. Okay. I might have clicked it by accident. It needs to be blue, right? It's blue. I think I don't want it, but I gotta tighten the shirt to keep it steady. Oh my God. Put this behind the collar. Yeah. I don't know. Can you put this on for me? It's pretty hard for me to do. I'm thinking wherever it's going to be pointed at. Yeah. Okay, hey, check. Check.
You're all good.
All right, cool. All right. I'm going to go ahead and get started. Just want to say this feels like history in the making. A lot of people think that it's over, and I think it's just getting started. Yeah. So the first half of this presentation I've shared quite a bit over the last couple years. I shared it first at Acapulco in 2020, not this last one, but the one before that, whatever year that was. Then I took it to Mariposa Freedom Fest, or Music Fest, or I don't even know, I forget the name. Where else did I take it? I took it one other place. Oh, the Crypto Vigilante Summit, that was online. The other two events were in person. I took it one other place. Where did I take it? Who cares? I've been talking about this for a while, and in interviews, you know, it's but I've actually removed every trace of what I'm about to share with you from the internet. And the reason I'm, you know, saving the latter half of this presentation is because every experience in my life where I showed up is when massive changes happen in my life. If I didn't sacrifice everything to be in the room, then I would have missed the boat completely. So you guys and gals, you know, recognize that it took a lot of sacrifice to be here, and the significance of that can't be understated. So for everyone viewing online, I hope that, you know, this bit of information is going to be helpful for you, but it's really just the first step in the direction. So let's begin. I always share this presentation with this statement. As humanity settles into the new age of Aquarius, more people will become mentally, physically, spiritually, and financially free than ever before in human history. Now, before I move forward, I just have to have some bit of a disclaimer. This is not legal financial advice. These opinions are based on my research. I'm not paid or endorsed by anyone at all. I wish I was. I'm not. I am an investor and supporter of Bitcoin SV, and my research and what I know is founded upon the experts that came before me. So, you know, if there's a source, I will give credit where it's due. So basically, I'll be decoding the title of this talk, The World Currency for the Age of Aquarius. And it's going to include some things that you may or may not have studied that might seem a little out there, but I can assure you that it's going to connect dots in a way that I don't know if anyone alive has ever done before. So we're going to use astrology, numerology, gematria, esotericism, cardology, mythology, historical events, fundamental analysis, technical analysis, and I don't want to talk about myself, but we would be remiss if I didn't include pieces of my own personal experience. Now, the first thing, astrology, I just want to get this out of the way. My Airbnb host was kind enough to give me a tour of the city yesterday. So we walked around for 4 hours. I'd never been to San Francisco, so it was really cool. I was definitely out of breath very quickly. But the photo you see here on the right is actually, I don't know if it is or was, but it is the residence of Joan Quigley, who died at the age of 87. Now, she was the appointed astrologer who advised the Reagan administration and the family. So before anyone questions, is astrology legitimate, consider that fact, and that we're in this city where this building currently resides. Can I click? Oh, okay. Oh, good. Yes, it shows me. That's beautiful. All right. Also, after I spoke at Acapulco a few years ago, my wife and I took a trip to the Yucatan. First time ever, too. It was so special to me. I call Mexico like God's country. My whole discography came out streaming to the world. I'm an artist on 2/22/2022. And that was the day that I landed at the Chichen Itza, the great Mayan pyramid, for the first time ever. A total coincidence because it wasn't part of our schedule. But when I was out there, I was able to somehow set up a meeting with the great Santos Bonacci, who I would consider the world's greatest living astrotheologist. So this is someone that studies religion, history, astrology, basically all the things we're decoding today. So they're a master of decoding reality and perception. And it almost brings me to tears just thinking of how much suffering this man has gone through sharing the truth over the years. But for about 20 minutes, my wife and I were able to just ask him our deepest, darkest questions. And I was greatly humbled. He read my astrological charts. He gave me some hydrogen water that he was like just so happy about. And when it came down to it, I said, Santos, like, can you prove that we're in the age of Aquarius? And he looked me in the eyes and he said, yes, we are absolutely in the age of Aquarius. And then he explained to me why. Now, I tried to record this in an interview, but he had just had some dental work done, so he wasn't up for it. So I actually have no proof or record of what was said. It's almost like it came into my consciousness, and it's hard for me to interpret what happened. But to me, it was like I went to the top of the pyramid to be like, okay, if there was anyone to ask if this is what's happening, that was the guy in the moment. And interestingly enough, Micah Dank, he's got a YouTube channel, Micah Dank Truth Bombs. Also, I met from the internet, like many of you here, has become a great friend of mine. We're working closely together now. He has worked for and is an apprentice for Santos Bonacci and adores Santos. And I would say that Micah is the next coming of Santos, because Santos really is, he's an elder man. I mean, he's getting up there in age, and I don't know how much more he can take of abuse. Micah is next up to fill the slot. So I've done a lot of work with Micah, and I'm going to share more of his work throughout this, but I recommend following him on YouTube, and he will drop a truth bomb just about every day. Oh, shoot. Yeah, so I'm one slide behind. Sorry about that. So yeah, that's Micah Dank. Anyway, also in 2011, I went through a personal experience I'll get into after the live stream. I ended up creating a custom drum set, which was a dream of mine, and that was in 2011. It wasn't until I bought the domain name ageofaquarius.org in 2019 where I realized why I went through that experience. Because this entire drum set is, I call it the drum set for the Aquarian age, because it's literally wood burned into the drums and hand painted, all the astrology, everything I'm going to be talking about today that I had no clue I was going to be involved in at all a decade later now. Yeah, we've come a long way. In 2019, actually, it was my wife's birthday, July 3rd, and we were having a few drinks, sitting outside. I'm like, you know what, let me just, I don't know, let me look at Age of Aquarius on Namecheap.com and just see if it's like available as a domain name. Something just came over me, and I couldn't believe it, but the .com, the .net, and the .org were available in 2019. It was not long ago. And I was like, there's really nobody trying to claim responsibility for this. Why? And if this was to be hidden, how come it wasn't just balled up and hoarded so that nobody could do something with this? But at the time, I had like $1,400 to my name, and I sent it to Coinbase. I bought some Bitcoin, and I sent it to Namecheap. I could have just bought the domain, but for some reason at that time, I'm like, I have to buy this with Bitcoin, and I filmed the whole thing. I haven't released that footage yet, but I did it, you know. And I bought the .org, which was the one I wanted. It was the cheapest one. The .com was 15, 20 grand. It's in the video, I forget. The .net was like 5 grand. And I got the .org. It's what I wanted, an organization, whatever that would become. And you know, 3 years later, I put together a team and worked with Pirate Chain, Private by Default Crypto, if you guys don't know. It's incredible. And they helped sponsor the first ever Aquarian Music and Art Festival in downtown Orlando, right in the heart of the city on Lake Eola. It was at the Walt Disney Amphitheater. I went through all the legal processes, deposits, to make this thing happen. It was stressful, but we did it. And not all of my goals were achieved, but the main one was, you know, all I can do is just show up, right? That's kind of the point of why we're here. We don't know where this is going to go, but I just wanted to show up because I knew that this date wouldn't happen for another 200 years. So we did it. That was the day that I publicly declared that we're in the age of Aquarius on 2/2/2022. And it was amazing. Bitcoin aside, let's dive into what is the Aquarian age. Now, and when did it begin? Why does it affect me, you, all of us, and what does it have to do with crypto? We'll get to that, right? So a new age, it's a measurement of time, right? There's 12 zodiac signs in the calendar, and each one of those signs in a macro scale equates to 2,160 years. Okay, so we're trying to get through the day to day, but the people that run the world are looking at time from a macro perspective because they're guiding creation, they're guiding humanity. So we just came out of the water age of Pisces, because Pisces is a water sign, and we moved into the air age of Aquarius on December 21st, 2012. After the 12 cycles of these 2,160 years complete, that's known as an epoch, or 25,920 years. So the whole, all 12 signs is just, it's like cycles of rising and falling, and ultimately ascension of human consciousness. Oh, okay, cool, thanks. Oh, they can't see them at all? No. Oh, damn, you guys missed out.
What's your Twitter handle do you have on it?
It's my band name, Be Love and Be You. 7 letters. And it's that everywhere. I locked it in everywhere.
Can you spell it?
BLUVNBU. It's a 7-letter acronym for the 7 chakras, but it also means be love and be yourself. Thank you. So, a lot of folks, Jeff Berwick including, talks about this. Crypto Rick, who I'm going to bring up later, about the Kali Yuga. That's another way of there's a lot of ways to look at astrology and time, but ultimately this is the way I like to look at it as I'm figuring this out. So yeah, let's just move on. So I think the Mayans got it right. So December 21st, 2012, the number got cut off. But, that was the end of times, or the apocalypse, right? But that was actually my traumatic experience that catalyzed all this, was just before this happened. And then 8 years later, it was December 21st, 2020, which is, that's the winter solstice every year. And there was a great, event happening, as above, so below. So we're affected by this, and it was the great conjunction of Jupiter and Saturn. So this is an artwork that my mother made, Carolyn. She does all my artwork for my songs, and this here. And it shows the water's flowing out of the pitcher. What's missing here is the young man holding the water pitcher. That is what Aquarius is. A lot of times you'll see the waves. It looks like ocean waves. But there's so much more to it than that. So this was a significant event, these planets aligning, Jupiter and Saturn, because it was in 0 degrees of the constellation of Aquarius. So I mean, gosh, if we weren't in the age of Aquarius already by 2012, that was it, So a big distinction between these two ages, the age of Pisces and Aquarius, is the age of Pisces is the age of belief. So the mantra would be, I believe, right? It was the age of Jesus, hence, you see the fish there, right? It's a big distinction, right? Because what's happening in the cycles that we're in is an ascension of human consciousness. So basically we're rising in vibration, we're rising in our awareness of self, of reality, and the process is releasing illusion. And ultimately the end result is true knowledge and knowing. So that's the mantra for the age of Aquarius, is I know. So it's this inner conviction that is undeniable in your heart, which I truly feel about everything I'm sharing today. And I can try to prove most of it, but honestly, that's not going to be possible until now with Bitcoin and blockchain. So moving on, when you're thinking about what does it mean to be in an air age of Aquarius, you look for the signs, right?
So those waves that look like ocean waves, actually a sine wave. So this is next. You got to read between the lines and next level decode this thing. And if you look around, these characteristics are so obvious. I mean, they've been obvious. I mean, if I can even go back before the information age of knowledge and the internet and the communications technology that we're using now, robotics and AI and NVIDIA just hitting $1,000 a stock, like what? It's crazy. But the Industrial Revolution was also massive. Like the printing press, all these things, that was great technology that got us to this point. I mean, we've been in this upward, awakening and releasing of illusion. But ultimately, I stand firmly that blockchain is the technology. It's the technology that was meant to transition humanity from the age of Pisces into the age of Aquarius. Now, nobody told me this. I'm not in the club by any stretch. So I had to figure this out on my own. And in doing so, I really began to trust the science. And then I learned that, I realized that, wow, they've been telling us this whole time to trust the science. And maybe half the population actually did. But I did trust the science, and I realized that when the lockdowns happened in 2020, and there was this virus in the air, and 6 feet apart, you wear the mask, and all this stuff, I was like, whoa, like they're spreading fear about something in the air. And I knew because a year prior I bought this domain name. I knew they're talking about the air age of Aquarius, hidden in plain sight. And if you know, you know. And if you don't know, you probably believe some shit. But I'm not here for that personally, I actually want to know the truth, and I want to live by it. So how does this lead to Bitcoin? Well, first, we got to follow the money. Yeah, that's one of my favorite things to do, is follow the money. Now, here you have this Freemasonic symbolism on the dollar bill. And mind you, we're standing in the first ever built Fairmont. This whole place, yeah, it's old, but it's a Freemasonic work of art. And I've been knocking on things, like, oh, how'd they build this? I'm looking at the architecture, and I'm just like so in awe of all of this. And then it brings me back to the dollar bill. So let's decode this a little bit. Okay, Latin is one of the oldest living languages in history. And that's why Freemasons use it. Because spelling, right, you use words and letters which equal numbers in different gematria ciphers to basically communicate sine waves. Because even my voice right now, you hear your brain's interpreting what I'm saying, but all it is a vibration that's shooting out of my body. Your brain is just able to compute that, but ultimately it's a sine wave. So at the top, Anio Coeptus, it says, He, God, has approved our undertakings. So I still kind of struggle with this to this day, but that is suggesting that everything we've seen over the last few thousand plus years, is in God's favor. The wars, the genocide, everything. I mean, that's a hard pill to swallow, right? Now let's get to the bottom, right? It's right there. It says Novus Ordo Seclorum. It says a new order of the ages. Like, what do you think they're talking about? They're talking about the macro aspect of time that matters more than anything on this planet, if you ask me. And you figure that out the way the ancients did. They would look up, not down, or not here on their phone. They're looking up, The Mayans were some of the greatest astronomers ever. So it wasn't coincidence they said, oh, the winter solstice on 2012, that's it. So obviously the Freemasons are behind much of what's going on. And they basically said here, we're in the age of Aquarius. So that's the dollar bill, right? The dollar bill is the most touched, felt, seen. It's world reserve currency. We've all seen it, right? So when you're trying to manifest something, there's like the law of 7 that Lutz would always say. Just get in somebody's consciousness like 7 times, and then they'll buy. Well, they've succeeded a lot more than 7 times with the dollar bill in establishing that symbolism, that message I just showed you, this message right here. You know how many people, the human consciousness, the collective, have seen and felt this and used this thing without even knowing what the hell they're doing? Your mind sees it. You feel it. You don't have to understand what it means. but it matters in terms of manifestation. So that's the that's the old money. We're going to talk about the new money. So this has been circulating now. I'm actually really happy to see the truth is starting to come out. This has been on my radar for a long time, but I have to give credit where it's due. It wasn't until Crypto Rick, or Crypto Current, his name is Rick, who Gavin interviewed, which I love that interview, twice actually recently. You've got to check both of those out. He actually did a decoding of this Economist magazine based around Bitcoin SV. And when I saw that, everything clicked for me, and then I was off to the races. And throughout the whole trial, Copa Be Right trial, I put together a 100-page report, basically decoding starting from this, as early as 1988. I'll be sharing most of that after the stream. So The Economist is not like some willy-nilly magazine. It's a think tank. Right? This is a group of very powerful and wealthy people that are highly invested in where the future is going. And I mean, you can obviously see that 27% owned is 26.7% is the Rothschild family, Exor family, Cadbury, Schroeder, Leighton. I don't know who those people are, but I know they're they're not here to just play games. So yeah, keep in mind. I mean, they have a staff of 1,600 people. Their services is intelligence. They hold conferences. They got the magazine. It's a whole thing, right? This is important. They told us on January 9th, 1988, what to do. They said, all right, well, get ready for a world currency. So again, subconsciously, that's what we've been doing, thanks to them. I'm going to break down, I'm going to decode just a few things on this, all right? That date, when this issue came out, mind you, when this issue came out, right, exactly 36 years later, to the day, was the day that the SEC leaked on Twitter that they approved spot Bitcoin ETFs. So it was the first time the Wild West of crypto in history was like maybe coming to an end. So 36, that's the number that I really want you guys to pay attention to here. It's going to connect all the dots that we've been thinking about. Now think about this, right? On this coin, you see the word 10, the number 10 in 2018. So 36 days from that date is the day that Bitcoin SV was forked. Exactly, to the day.
36 days from what?
10/10/2018. So 36 days from then was November 15th, 2018. That's when BSV forked. Coincidence? I don't know. What else can I say about it? Should probably just move to the next slide. All right, so exactly 36 years from the date of the calendar, and then 36 days from the date that was on that coin, you have BSV. Okay, why is that important? Now there's 4 base ciphers in Gematria. I'm missing Chaldean up here, but you can see that reduction is it's so basic. It's addition, subtraction, you know, and it's 36. Bitcoin is 36. So is it XRP? Is it Solana? What's this world currency they're talking about? I don't know. Is it CBDC? Well, who cares? I think it's Bitcoin because they're telling me right here in the code. Now, before I get to that, my God, there's so much I'm going to share with you guys after this. And there's more to 36 than I can even remember right now. But I think the Bible is incredibly relevant now more than ever. Christianity being the predominant religion, Islam being second. The Bible to me it's a prophecy, and the prophecy is coming true. So there are sections in the Bible about the mark of the beast. You've heard 666. Ooh, that's scary. I don't know. Well, 666 is the 36th triangular number. Now I checked Solana, I checked XRP, I'm checking different cryptos. None of these have the coding of 36. None of them. But Bitcoin does. and just Bitcoin. Nothing else, no SV, it's OG Bitcoin, right? All right, so keep that in mind because we're going to talk a little bit about what 666 means. We're going to dispel the spooky. All right, so we are carbon beings. I mean, this is science, right? I'm trusting the science. And the molecular structure of carbon is 6 protons, 6 neutrons, and 6 electrons. Now, I'll just read this. Revelation. And he causeth all, both small and great, rich and poor, free and bond, to receive a mark in their right hand or in their foreheads, and that no man might buy or sell save he that had the mark, or the name of the beast, or the number of his name. Here is wisdom. Let him that hath understanding count the number of the beast, for it is the number of a man, and his number is 666. Notice the number of a man, and I said what Aquarius means. It's the young man holding the bucket of water. But beyond that, the anima, the beast, it's us. It's not just carbon on a scientific matter. You're talking about us, and then you guys have heard of Microsoft patent 666, and that was about like your phone like tracking you on chain or something, counting your steps. Basically, I hate to say it, I guess, but Bitcoin is the beast system, from what I can decode here. And it's not something to be afraid of. It's something to look deeply on and understand, in my opinion. Now, from a tech side, obviously it's Bitcoin in its original design because it's already got the largest decentralized mining network. Because keep in mind, if you ask me, this has been a 36-year plan, at least. Started in 1988 when that magazine came out, They knew what they were doing, what they were building, and they figured out who was going to help them build it, whoever they are. So it's pretty established now. I mean, in terms of proof of work, you're not going to find any competition to Bitcoin. All right, if we had to switch to blockchain tomorrow, it's Bitcoin. And if it had to facilitate the world's transactions, well, it's BSV because we need that TPS. All right, so Craig Wright was first to say it before anyone else, but Xiaohui blew my mind with it. Bitcoin is a Turing-complete supercomputer. So it can and it will do everything. You don't even need a layer 2 solution. So Lightning, SegWit, Taproot, all that Frankenstein shit can go out the window. It really is the true Web 3.0, which I'm so excited about because I'm so done with Web 2. I've made like no money with Web 2. Bitcoiners, helping Bitcoiners is what Raphael there really has been driving home. It's like if you're in the new Bitcoin economy, everybody wins, and we're here to help each other succeed. And that's a beautiful thing. Also, it scales horizontally on chain. So, Lutz from Pyrochain, right? He always says scaling it doesn't matter until you get to that point. And I think there's some merit to that. Like, yeah, BSV can scale, but we need users using it before who cares, But at least we know it's possible, and we're testing for that. But scaling horizontally on chain is so important when you're considering the hardware components and the storage components, everything that goes into the technology behind this. And obviously, Bitcoin in its original design can do smart contracts, and thanks to sCrypt and the work that they're doing, it's becoming easier to do. So for a while, I was of the opinion that ETH was the new thing because it could do smart contracts, when really, even Vitalik always knew it could do smart contracts. So what kind of game are they trying to play? I actually got this from the BSV Association, that BSV, despite being first, it is the best. And that's a bold statement, but it's meant to be investigated. And the good news is we're just getting started. So I'm really here today, honestly, because of Rafael Laverde. If you don't know him, check out cryptovigilante.io. Before I started working with the guys personally, and Raf offered me a gig to do some interviews and push out the information. This event came up thanks to Jack Liu. It was the last Cambrian SV to date, and that was when I met Xiaohui. That's when I met Jack Liu, I met Kevin. Where's Kevin? Oh, there he is. Okay, I met Kevin. Right? So Alex AV was out there. It was mind-blowing because this was before Ordinals and, one sat and all this stuff. Like we were like on the cusp of hyper-Bitcoinization. The Bitcoin Emperor was there. Daniel Craig was. It was the greatest gift from, honestly, I can't thank Raph enough for just taking me out there on a whim before I even had the job. But we bonded like brothers and sisters. There were about 20 or so of us. Some of the best Bitcoin developers in the world were in this room. And, we figured out a lot of stuff. But I think what was really the most profound thing that blew my mind was what Xiaohui did. He showed up like fresh off the plane from San Francisco. And he's like, hey, I figured out how to do zero knowledge on BSV. I'm like, what? Like, don't you know that I wrote a song for Pirate Chain? Like, I'm the pirate guy. And they're like the zero knowledge coin, And like now you can do that tech on Bitcoin. I'm like, well, I don't know if it'll be private by default. If it can be, why do you need Pirate Chain? Why do you need Monero? Honestly, if you can do that private by default, but if you can't, you can probably get pretty close to optional privacy. So that is groundbreaking and it's worth exploring, in my honest opinion. And that's a blog that interview that Raph did with Xiaohui on the beach. It's awesome. This is all history in the making. Like, people are going to go back years from now and look at these interviews and be like, whoa, where was I? So this is really cool. Dark5 put out a YouTube video, still out. It's like 9 minutes long. And Alex AV, Freenotch, showed me this one time when I was crashing at his place on the Florida coast. And he asked me, he's like, so Matt, what do you think about BSV? This is before Cambrian and all this stuff. And I was like, oh, I'm open to it, man. Raph is pretty pumped about it. And that's when I saw Alex's heart around the technology. I knew that he was very real regarding this and had struggled with even sharing this with anyone, that he was passionate about Bitcoin in its original design. So we watched the video, and I encourage you guys to watch it. Dark5, they talked about solar punk technology versus lunar punk tech. So I explained this in all these events I was at, Anarchapulco, etc. But this is all esoteric. The technology is esoteric, right? Solar punk, sol is the sun, right? So that's the yang. And lunar punk is the moon, which is the yin. And what has been missing so much from the whole industry, among many other things, is like the patience and discernment to know the difference and then actually factor it into what's important to build. So like solarpunk tech is obviously transparent ledger. That's like Bitcoin, Ethereum, Tether. It promotes extreme capitalism because it's really public chain. It's out there for the world to see. FTX crash, well, it wouldn't happen if the reserves were on chain. They had proof of reserves. And as Raph says, it promotes honesty chains. I like that. I think we need more of that in the world today, and that in part promotes trust. That's great. Now, I personally don't want my entire financial history of transactions out there for people to see, even if it's like anonymous or hard to figure it out. So that's where Lunarpunk comes in, and that's where you've got Monero and Dero and Pirate Chain, and these are private ledgers, private by default. So that's for extreme privacy. This is a polarity here, like in all things, the polarity of extreme capitalism and extreme privacy. Got to have both. Like that's the balance, because Libra, I am a Libra, and that's an air sign too. So it's really relevant for this air age of Aquarius. So my personal finance, I'd be sending transactions in Pirate Chain, Monero, etc. There's the bad news to this is that the Lunarpunk tech can empower bad actors, and it has. It's facilitated money laundering and human trafficking, the biggest crime against humanity, in my opinion. And that's that. But the reality is, where I disagree with most of the privacy communities, like you can't run and hide forever, And I don't want to live in a world where I have to run and hide. That's why I love Bitcoin. I love how honest and open it is. Let's expose it all. Let's just uproot everything. Just come clean, all of us. And that's where I think this is going. So before I move on to the next part, I do feel that we have 23 days to really decide where you stand on all of this. My first self-published book also came out in 2022. Was The Last Stand, How to Thrive in the Age of Aquarius. 66-page guidebook, by coincidence. And this is your chance to take a stand, basically. And I think you got 23 days. Why? Because in Chaldean, Bitcoin SV is 32, and Bitcoin is 23. Now, the way the mind works, when you see numbers, it sees all possibility. It just records it. You might be looking at a 32, but your brain's going to see 23 as well. Maybe it's going to see 2 plus 3, or maybe 3 times 2. It's going to see all of the possibility within it. Like we are supercomputers as well, just organic ones. And this is why. So there's a lot of very strange parallels to this band and this man to my life story, which I'll get into later. But more relevant than ever. I mean, who was at the Super Bowl sitting next to mega stars Beyonce and Jay-Z while the COPA trial was just starting? Yeah. There he is. I'm sure he hangs out with them on the regular. Yo, Jay-Z, what's up, man? Yo, let's talk some tech, bro. Yeah, okay. So to me, all that was totally scripted and staged, right? And it was shown specifically at the right time, again, to capture the attention, to create attention, to manifest whatever it is the powers that be want to manifest, right? So they're drawing attention to what's happening with Bitcoin. The whole Super Bowl was about Bitcoin, which I'll get into later. But the shirt that he was wearing was a Nirvana t-shirt. Of course, it was, it said Satoshi instead of Nirvana, but it was a Nirvana t-shirt. All right. Now, Kurt Cobain, it's like Satoshi. It's a big mystery. How did he die? Well, I know that he was murdered, for sure, because there's no coincidence that he had just happened to die at his age when he had the whole world ahead of him on April 8th, 1994. Now, exactly 30 years from the date that Kurt Cobain died, the lead singer of Nirvana, up until what's happening on the 8th of this year in April, is not just 30 years, but it's 360 months. Now, in numerology, anytime there's a 0, it's the void. Me and Brett were talking about this. I'll tell you, we were the last ones standing last night. I got to give a shout out to Brett because that dude is just amazing. I know. And last one standing. So we're going deep in the geometry, the sacred geometry, the numbers, what's going on in the world. And we found out that 36. You just cut the 0 off. It's the void. It doesn't matter. And you got 36. Bitcoin is 36 in reduction. It's a 36-year plan at minimum by the powers that be. The date on the coin in the Phoenix Economist issue, 36 days later, BSV was created. There's a lot more parallels to 36. But if that's not enough to get you to wake up and look at this, I'm talking to everybody on the stream, because you guys get it. I don't know what is, and I'm honestly not trying to twist anybody's arm about this, but on the anniversary of Kurt Cobain's death, 360 months later, is a 7-year eclipse called the Great American Eclipse, which is incredibly rare. For this to really focus on the United States, I don't even care to know the numbers. Just go greatamericaneclipse.com and you'll be like, okay, wow, this never happens. Damn, maybe I should go. Well, thanks to dear Amy, who's in this room, I was actually at the one in the middle. It's the story of my life, the Libra. I'm always in the middle. I'm like stuck in the middle of good things and bad things. This was a good thing. So it was SolarPunk. This is the SolarPunk Summit. That was the other event that I spoke at. So I was speaking there, and prior to going, a friend of mine who runs the bookstore in Casadega, which is like the oldest spiritualist settlement in America, just 40 minutes from my place in Orlando. I just popped in and she was there, and she's like, I told her I'm going to Texas. She's like, well, you're going to the eclipse? I'm like, what are you talking about? And I'm like, okay, I'm going. But it wasn't until I was at the festival and I'm like, how do I get there? And Amy let me use her car. And I just drove out and I did it. And I this whole booth and table, all this stuff, I set it up. And I was out there with all these, in the public, with all the normies and stuff, just with my Age of Aquarius stuff and my guitar and the Bitcoins and everything. looking at the eclipse, and it's on YouTube. I filmed the whole thing. It just felt really symbolic. And also that eclipse was in Libra, which is my sign. So anyway, these 3 eclipses, they put 3 X's across the United States, well, really North America. The first one happened here. Can I read that? That was the, August 21st, 2017, total solar eclipse. Created it's an X over the Cascadia subduction zone. So these zones and these fault lines are where tectonic plates would, have come together. So it's almost like a scar that never fully healed, right? So there's a lot of seismic activity that can happen, earthquakes, tidal waves, things like that. When you're thinking about Mother Earth, it's important to consider the path of these eclipses. So that was the first one, but the second one, the one I was at, was October 14th, 2023. That goes over the Balcones fault zone, that one over there. And this next one coming up is going to be on April 8th, 2024, and it's a total solar eclipse. I mean, it's epic, and that's going to create the last of 2 out of 3 X's over this country. So what does that mean? Well, how much am I? All right, I'll give you guys just a little bit more because we're going to dive into this more deeply next. Whoever wants to stick around for that. So do you see how I put 4 red circles in the middle of the big X over the New Madrid fault line? Like, I mean, that's serious. That one there is like, that's the big one. The government has had immense reports done on what would happen if a large earthquake hit the area. It'd be devastating to our country. I'm not saying that's going to happen, but I'm saying that something's going to happen. And we have 23 days from now to figure it out. But those 4 circles right there, there are, I'll start with the first one on the left, there are 12 district banks as part of the Federal Reserve. The only state to have 2 of those district banks in it is Missouri. So why? MO, what's the modus operandi? What's going on here? So you got, obviously the St. Louis Fed right there on the Mississippi. But then, what do you know? You've got the Kansas City Fed. District 10 is Kansas City. District 8 is St. Louis. All right, so yeah, this is going to create an X right through these 2 banks, and obviously the dollar is still the world reserve currency, but I don't think it's going to be for much longer, or it's about to transmute into something new, and we, us in this room, we have an idea of what that might be. It's just an inkling of what that might be. But not to mention the southern tip of Illinois, if you look it up, the region is called Little Egypt. It's called Little Egypt. So go down that rabbit hole, search UBTV on YouTube, and learn the history. Search what? UBTV on YouTube. And there's hundreds of hours of this one guy that just decoded the history of America. I mean, 20 hours in, I'm convinced that America is Egypt. And what's playing out today is the karma of a country founded on blood, essentially, and blood money. So for us to really enter the Aquarian age, we have to bring that to light. All right, people need to know the truth and what's happening. Then we need a solution to transmute it. I'm pretty clear on what the solution already is, at least in my mind and heart. But it's not going to be easy to figure all that out. So there's that. And then the last circle here was the Georgia Guidestones, which I thought was the weirdest thing. If you don't know about it, it was constructed March 22nd, 1980. It's like a Stonehenge in the U.S., but it's like middle of nowhere, Georgia, Elberton, Georgia. And I was like doing some recording in Tennessee, and my wife and I were like, "You want to like check it out?" So yeah, we took a little detour and we went, and it was the creepiest shit I've ever seen. I mean, we go, there's nothing around, there's like cameras there, and I filmed everything. It's on my computer. I got videos, photos, and I'm glad I did because it was destroyed on July 6, 2022. Now, the way that, at least in Latin, what is it, orbo de chao, order out of chaos. You've heard that, right? the way that the masters of this realm work is that they, from death comes life and rebirth. So destruction and a clear ending of something is usually the start of something new. And the way these folks work, they always have a plan for what's next. So I believe that the guide stone's getting destroyed. It means that it's on. I don't know what it is that's on. I completely, but I got a pretty decent idea. And that's all right in the X. So, I got a lot more to share. I intentionally reserved the last of my talk here for anyone that wants to stay. We have the room till midnight. I'm going to do some whiteboarding. I'm not going till midnight, but I'll go as long as you guys want me to, and I'll answer all your questions, and I think we can actually have a really intellectual conversation here, like mastermind what's going on. When I wrote this report, this 100-page report on the world currency for the age of Aquarius, I reserved it for the high net worth investors that I know, who believe in me as a person, as an artist, a creator, as a Bitcoiner, to help secure my future in this new Bitcoin economy. Because not only do I want to get positioned in a big way, personally, I'll be honest, but I want to start building stuff, man. I've been trying to build stuff since Cambrian SV, and it's hard, And obviously, like Xiaohui said, we're short developers, so that's a huge opportunity in itself. But I just want to get going. I want to get moving on this. So we're going to get into all that, but I'm just going to leave you guys. Thanks for tuning in. Definitely check out tomorrow. It's a lot of this information as it comes to light. It's going to be hard pill to swallow, but the sooner the better, in my opinion. If you need help or have any questions, you can always reach out to me on ageofaquarius.org or the team. We're there for you. It's not easy for us either, but no matter what happens, just remember. It's always be love and be yourself. And that's all I got.
All right. So thank you very much, Matt, for sharing that portion of your presentation with our online audience. This wraps up the day one online live stream for the sCrypt Hackathon. We'll be starting for the stream audience tomorrow at 9 a.m. We've got Teranode, we've got Thomas Giacomo of the BA. We also have Jack Liu, I believe, in the afternoon with a little panel, and some other great presenters. So you have a lot to look forward to on day two tomorrow. Be sure to follow us on Real Coin Geek Twitter, Babbage, Project Babbage on Twitter, sCrypt platform, BSV blockchain, and so for the live stream audience, thank you very much for tuning in to day one. And we'll see you tomorrow morning. So we'll give them a good send-off here, guys. Thanks. This has been amazing. This has been really amazing.